Hey guys, hope you're doing good. So let us cover integration of second semester maths today. Let me make an attempt at teaching you all a basic understanding of the whole chapter. And yes, let's top it off by solving all the classwork problems. So let's get started. Yeah, so let us start off with a very simple analogy on what single integral is, and let's compare that with double integrals. So in single integral, just assume that you're standing and in front of you there's a wall, and say there's this curve given to you, and you're required to find the area under this curve. So basically that's going to be this part of the curve. So when you're seeing it like this area is just a simple 2D figure. In integration term, it's basically you having a graph and a function, and you're given a lower limit and an upper limit, and your job would be to find this area. And for that, you have this function f of x, and you have the limits. Your job is simple. You just use a single integral and put the limits, and you're going to get the corresponding area. Whereas when it comes to double integral, I want you to just look upside, and you're going to see your ceiling, and say there is a curved surface dropping from your ceiling. Like say there's an inverted dome structure, okay, and you're required to find the volume under this curve, basically this part. So in this, you definitely can't use single integral. Single integral alone is not sufficient. So for this, just one more thing here. Here what you essentially do is make tiny strips like this, and very small, very small, and you just sum it over. Over here you're doing a similar thing, but the strips you're taking are something like this. Basically, you can imagine them as 3D strips. They're gonna have a small width of dx and a small width of, or say, height dy, and you're gonna be again summing it up like this, and also summing it up like this. So you would need to integrate. Essentially, you're integrating it twice. So assume that let me just take it in the form of a graph. Oh wait, yeah, it's like difficult to draw, but never mind, I'll just not draw the graph. So just assume that it's given in the question that x varies from 0 to 5 and y varies from say 0 to 10. That is basically, in this situation, it's like ಇಲ್ಲಿ 0 ಇಂದ ಇಲ್ಲಿ 5 ವರೆಗೂ ಹೋಗುತ್ತೆ, and y ಅಂದರೆ basically, maybe, yeah, my bad, I had to take the origin from here. So 0 to 5, and y is 0 to 10, ಇಲ್ಲಿಂದ ಇಲ್ಲಿ. And in integration, it's just, and this function, the dome function, it's basically in the form of f of x comma y, because each point on the dome can be represented by x and y. Basically, it's varying with both x and y, and obviously our dx and dy. And here x will vary from 0, and the upper limit is 5. Y goes from 0 to 10. So it's like you're summing up all the portions here, and then you're summing up this part. So it's like summing this followed like this, and at the end of the day, it's going to give you a volume of that room. So if this is your room, it's going to give you that shaded part, and you're standing over here. So I hope you got this basic difference. So let's come to another interesting concept here. Just assume that you have say a function given as dx dy, and they've asked you to they've given you the region. Okay, here if it's written like this basically means you have to integrate this in the given region. My bad, it's not r, it's this r. Yeah, and say the region they've given is y equal to x plus y equal to 4, So once you plot all these, you're gonna get a graph which kind of looks like so here you have y equal to 1, here you have y equal to x, and what was this? This is your x plus y equal to 4. And they've asked us to find the the region bounded by these lines. That is basically gonna be this part. So you want to find the region under this, and what are the ways in which you can do it. One thing is you take a small strip here and you sum it up till here, or the other way you can go about is take a strip like this and you sum it up like this. You just keep on adding this. So you have two different ways. So this is basically your vertical strip. Oh my bad. This is your horizontal strip and this is your vertical strip. But the thing with taking vertical strip here is that you have to break your figure into parts, because say you're taking vertical strip. The core idea about taking strip is that the strip varies from the first position and goes to the second position. In this case, what are the values of y which are changing? Here this is the origin, by the way. So y is 0 here, and y over here is just y equal to x. So in this part, y is varying from 0 to x, whereas when you come to this part, y is varying from 0 to 1. So 0 to 1, and when you come back here, it's another story. It's like y is varying from 0 and it's going till the equation of this line, which is 4 minus x. You can see you have to split it into 3 regions and you have to add the result together to get the final area under this part. Whereas if you consider a horizontal strip, it's gonna be simple. It's gonna be much simpler for you. So in this case, x is just varying from this part, whatever this is, to this part. Or this part is basically what I meant. Like what I trying to tell is it's like an arbitrary point here, and here also it's an arbitrary point. Basically the points on this line, on these lines. So you can see x is varying from here, it is y, and here the value of x is 4 minus y. So x varies from y to 4 minus y. You have one region compared to 3 regions. So clearly this is the winner here, and you have this is going to make your task much simpler in integrating it, and this is just gonna be, it's gonna take lesser steps. So let's go to the next one, which is basically you're changing the order of integration. Assume that you've been given a function, I mean you're given the integral so you've been given this. The first thing which will strike in your mind is, wait, we have e power x square. I don't know how to integrate that. So if we don't care about this for a second, and mainly in double and triple integrals, our main focus would be on the limits. If you get the limits right, half of the question is solved. It's that simple. So let us worry only about the limits now. You can see x is varying from 3y to 3, and then y is varying from 0 to 1. So if you just plot this, x is what, 3y. So this is how x is gonna be, and you have x is equal to 3, which is this, and you have y equal to, this is y equal to 0, and you have y equal to 1. Yeah, somewhere here. And now in this itself, I'll teach you one more concept, which is gonna be how to identify the shaded region. So they've told x goes from 3y to 3. So what is 3y? This is your 3y, x equal to 3y, and they've told it goes from x goes from 3y to 3. Basically it's a strip which goes from 3y to 3. So consider this strip. It has to be this strip because it goes from 3y to 3. You'll be like, why can't, basically this is the shaded area. That's the first thing. So you might be wondering, why can't we take this as the shaded region? Why is this correct and why is this wrong? That's because they've told 3y to 3, and that's gonna be this, and they've told y equal to 0 to 1. So y equal to 0 to 1, this blue line. So I hope you understood why we take this part as our required area. So coming to the main point, which is change of order. That is essentially just flip the strip. Here you can see y is from 0 and 1. So that means, this is one more tip, which is like in double integral or triple integral, the outermost integral should be having constant limits. So judging this question, we can tell that y is the outermost limit. That graphically it means that the strips are see y goes from 0 to 1. So that means the strips have to be taken like this, because only then the strips can go from y equal to 0 till, if you zoom in and you take a very small strip here, it goes to y equal to 1. So that's why the strips you have to consider here are going to be of this, this or this direction, or in this way, and it goes from y equal to 0 to y equal to 1. And change of order is basically you are transforming this and changing the strip to something vertical. So rather than considering the strip like this, let's take the strip this way. So now tell me what our limits are going to be. First of all, what is this? This is y equal to 0. And what is the value of y here? Y here you can see it's x equal to 3y. So y is just x by 3. Y is x by 3. And what are the boundary values of x? So this strip, it starts from this point and goes all the way till this point. So the value of x changes from x equal to 0 से लेकर x equal to 3. So you have y varies from 0 to x by 3, x varies from 0 to 3. As I just told that the outer integral should have constant values, that is being proved here. X does have constant values. So we have successfully changed our order, and with this what we can do is, let's rewrite it first of all. So outer limit is 0 to 3, and y goes from 0 to x by 3, and our function is e power x square dx dy. Yeah, one more thing. Usually it's preferred to or suggested to write this one in order. Like you're now is the first part you're gonna be integrating it with respect to y. So that's why rather than this, write it as dy dx, because first you're integrating with respect to y, and the answer you get, that answer you're integrating it with respect to x. So you have this integral now. So e power x square is just gonna e power x square is just not dependent on y, so it's gonna come out e power x square, and you have just integration of dy, which is basically y, and you put the limits as 0 to x by 3, and then you obviously have this part still left. This is just gonna be 0 to 3, and yeah, x by 3 minus 0 dx. Just bring the 3 outside. You get 0 to 3 x square x dx. Now the thing is, this can be integrated, because we can take e power x square as t, and this is just going to be, if you differentiate this, you're going to get, using chain rule, you'll get 2x e power x square dx equal to dt. Now the fun part here is you have this term, and in the integration you have this term. So you can just replace this part with dt by 2. Basically send this 2 here, and it can be integrated easily. So hope you understood that. Now let's come to one more important topic, which is what is it? Oh yeah, when will the region split? You know we took this case where we had multiple regions. In some cases, even though we take a single working strip, it's gonna get split into when there are multiple regions or different regions. So for example, you're supposed to find the region bounded by these curves. So once you plot these curves, you're gonna have one second. Yeah, just ignore. Okay, it's like a very rough diagram. This is your y equal to 2 minus x, y equal to x square, and yeah, essentially the area we're required to find out is this part. So here, say we are asked to take strips in this direction. So fine, you'll start taking a strip here, and as the strip moves, oh wait, yeah, first of all tell me what are the limits for that strip. So if you take this, it is sure that what you'll be judging is the x value. So here the value of x is 0, and here the value of x is 2 minus y. Okay, fine, you come here. Is that the same? Yes, 0 and 2 minus y. Whereas you take this particular line, anything after this, if you consider this strip, here at 0, I agree, but this point the value of x is not equal to 2 minus y. It's gonna be following this equation. So x is just gonna be root y. So what we figured out now is that it has to be split into 2 regions. One is this red region, and the other is this purple region, and we'll just have to express it as two double integrals, add them, and that should give you the answer. In classroom problems, I think that situation will come. So and during that time I'll explain it in detail. So next, coming to Jacobian. So yeah, Jacobian will be really handy when we're solving classroom problems and basically in integration as a whole. So it's like, you know how say you consider a circle in Cartesian. You know what's Cartesian? It's basically having variables as x, y, and also z. Here the points you'll measure is like 1 2, like 1 2 3 4 and so on, and same here 1 2 3, my bad, 1 2 3 4 and so on, and here it's obviously negative. Whereas when you find that this curve is difficult to handle in Cartesian, you must find another graphing system which is going to simplify stuff, and it should let you solve a very complex problem using the variables of the new curve or the new system. So one such very helpful system is polar. So in polar, how in Cartesian we have x, y, in polar we have r and theta. So if you take the example of a circle, oh yeah, and the equation here is x square plus y square equal to, say the radius here is r, so it's going to be r square, we know this. Whereas in polar, we'll just, yeah, this is where the actual fun begins, because you'll have to be comfortable with this graphing system to actually, easily solve the rest of the chapter. So the parameters here are going to be the same. It's theta and theta, and say we bring back that circle and it's of radius r. So the way we represent this circle is by making a use of obviously r and theta, and the rule of thumb when you're using polar is, see how your angle theta is sweeping and see how long each point is getting from the origin. So if you take the case of a circle, say you consider a point here, and theta is basically your point moving like this, and yeah, this is theta. So in this case, oh yeah, and also I'll explain about r. So let us consider this as our vector. So in this case, you can see that r is like, the vector is almost null vector. Basically it has zero length. But if you keep increasing this, you can see its value is like obviously increasing, as I told, but it's varying from 0 to r. You can tell for a circle, like say this distance from origin right now is r, and say this is obviously theta remains the same, and if you keep the value of r the same, that is this length is same, whereas if I just keep on increasing r, theta I mean, you're gonna get this sort of a curve, and obviously that's a circle. So yeah, that's the main concept of polar, where you're varying theta and r to draw that graph. I think we'll take the example of we'll take the example of sine 2 theta question. There's a question like that that might simplify stuff. So the question goes like, you have to integrate over the region r, and the given region is basically sine 2 theta. Yeah, So this part is a key step, because you know how in Cartesian this goes to infinity, infinity minus infinity minus infinity. So if you want the entire region, you would want to vary x from minus infinity to plus infinity, and y you would want to range it from again minus infinity to plus infinity. Whereas here in polar, so in polar, if you want to cover this entire region, what you have to do is you'll have to vary. First think of this. You definitely want everything which is in this blue part, basically your first quadrant. You want everything which is in this purple part, which is your second quadrant. Similarly like that with third quadrant and fourth quadrant. So to map all these areas, you will have to vary your theta from 0 to 2 pi, so that it covers the 0, pi by 2 and so on. You get 2 pi, so that you cover the entire direction of the coordinates. And just covering the direction is not okay, because this is technically you have covered the direction in drawing the circle. But what we want is not just covering the direction, but also covering the entire portion, all this part. And to do that, we just have to vary theta from 0 to 2 pi, which we just talked about, and r should go from 0 to infinity. And one important thing is that r can't be negative. Yeah, so I hope you understood this main aspect of polar curves. So if they've told 0 से लेकर pi by 2 andre, it's gonna be theta will vary from 0, theta equal to 0, and this is your theta equal to pi by 2. And remember one thing, it's not theta and r, it's not like that. This entire thing is theta, this is also theta, this is also theta, and r is just this length. So this part is gonna be this region all the way, extending to infinity. And they've also given r equal to sine 2 theta. We'll discuss that in detail when we're actually solving this question. But to explain this question to you all, the graph of sine 2 theta is something like this, like a double dumbbell shape, you might think, or whatever. Yeah, so they've mentioned that the region is 0 से लेकर pi by 2. That means it's just this part, and you should eliminate all this. Yeah, so our main focus should only be on this arm of sine 2 theta. So here we want to find out what the value of r and theta are. So you can obviously tell that, if you zoom in at this point will actually be touching the graph. So it's like something like this. It's not touching here obviously, but it goes close. And once you zoom in at this part, it is going to touch. That's why you must include, like, theta goes from 0 to pi by 2. I know it sounds silly, but I mean, it sounds silly that I'm explaining it in detail, but yeah, that's it. And what about your r? R goes from 0, because at this point r definitely is 0, and it goes till here. And here you might tell that the value of r is different here, value of r is different here. So how can we represent r in just using one notation or one representation? Yeah, that's when obviously your functions come into play. So what is the graph of this function? It's just sine 2 theta. So r at this point, any of these points for matter, any of these points, the value of r is just gonna be sine 2 theta. So yeah, we got our two heroes now. Theta is 0 to pi by 2 and r goes from 0 to sine 2 theta. So yeah, that's why in some of the cases where it's like it gets really complicated, maybe you take this situation itself, it's difficult to take the strips and uh, you know like actually integrate. Maybe in this I'm not sure, but in some of the curves it becomes very tedious to solve it in Cartesian, so we'll have to convert from Cartesian to polar, which is going to simplify our lives by a lot. So hope you guys understood the basics of like double integrals. If you did, I think the next part, especially the polar part, that's pretty important. If you did understand, I think your triple integrals will become simpler. Yeah, one small thing I forgot to tell over here. We told about the function here, but what about theta? It definitely varies from pi by 2. I mean theta to pi by 2, but I want to give you a more in-depth explanation about theta. So when you're plotting it, you would have understood it, but as we are memorizing this figure, it's like I forgot to explain it. But yeah, even when you're plotting, it just takes like some extra time to put in values for theta and get the values of r, and you'll not get a very direct you won't get a direct picture of how the graph is going to be like, because once you put theta you get r, say as root 3, and then you get it as 0.5, 0.4. It's going to be very difficult to draw. How you remember I told you that this line has a radius r, this has a radius r, and each of them varies according to the function. So if I got the values as root 3, 0.5 and 0.4, it's very difficult for me to draw a line which is 0.3 centimeter or 0.3 millimeters. And with respect to that also, I don't know how to draw root 3, how to draw 0.4, 0.5. I'll get a basic I'll get a basic measure of the length of the lines, but it's not gonna give me a very pleasant graph. I'll have to manually think and smoothen the curves to actually figure out what is cooking. So here theta, yeah, so approximately if you tell this is going to be 30 degrees and this is going to be your 45 degrees and this is going to be your 60 degrees, so and this is 0 degrees, 90 degrees. This is what I forgot to mention. And when you put say 45 degrees, you would have gotten some value that I think is going to be 1, because sine 2 theta, so this length would be 1. Whereas if you put it as put the value of theta as 30 degrees, it is going to give you root 3 by 2. And the same part here, like when you put theta as 60 degrees. So for different values of theta, you're going to get the different values of r, and that if you plot, you're going to get the graph. So yeah, now talking about Jacobian, you were in Cartesian, right? And you want to go to polar. We have certain substitutions which you can use. They're like x equal to r cos theta, y equal to r sine theta, and hence you get x square plus y square equal to r square. And if you divide these two, you're going to get theta as tan inverse y by x. So integration is like, fine, I'll allow you to go from Cartesian to polar, but you have to pay me a small price which is called the Jacobian. And the way you find out Jacobian is using this formula if it's in 2D. So say you have the variables x and y which are independent of each other, and say that depend on u and v, each of them. So we can write the Jacobian as basically like the partial derivative of x and y with the partial derivative of with respect to u and v. And if it's in 3D, it's just say x depends on u, v, and w, and so does y. In this case, just you get an additional term which is all x on this side, y on this side, z on this side. So dou x by dou u, dou x by dou v, dou x by dou w, and same thing for dou y, all that stuff. And you write this as dou of x, y, z, because you have dou z here, by dou u, v, w. This comes in handy for triple integration. This comes in handy for double integration. And you have what is called an inverse of Jacobian, which is just flipping these. And proof has it that j dash is gonna be 1. And for polar, if you want to go from Cartesian to polar, the Jacobian you're gonna get is r. We'll discuss about them. We'll discuss about Jacobian for other triple integrals also. But yeah, for now, remember that Cartesian to polar, if you're converting, the Jacobian is gonna be r. Hey guys, so continuing from triple integrals. So in case of triple integrals, this is gonna be the general case where the innermost integral is gonna usually be of two variables, like the limits I mean, and the next one is just gonna be a function of one variable, and the outer limits are mostly gonna be like they have to be constant. So yeah, it's like Andre, when you've taken say this part, the dx part, you should treat it as a normal integration, what you always used to do, and the value you get or the function you get after integrating, after you integrate this, you're gonna get a function, and a function idalla adana y respect jothe integrate madu, and other like when you do that, you get another function, and e function na you integrate it with respect to dz and put the limits, the constant limits, you'll get your answer. Now let's take this example where this is the simplest case where you can just split the terms with their the differentials. So it's like if they've given it in this order and the limits are constant, that means you have to follow this order. You can't interchange these because then the limits will get changed. So if it's given as constant limits, then your job would be to retain this order, and basically you have to open 5 2 with dz, then 2 and 1 with dy, and 3 and 2 with dx. That's just you can you can basically just distribute it. Dy, oh my god, you have x dx, here you have y square dy, and you have what, 2 5 dz. Integrate this, and yeah, that should be your answer. After this, we're moving to a very chunky boy, which is cylindrical and spherical. These are like half of unit 1. So coming to cylindrical, that's almost familiar to you because it's just like one step above polar coordinates. You can see that all the substitutions, they're literally the same. It's just that the core concept is just an addition of the z dimension. So say we take 3-dimensional plane, and say we have a cute little cylinder here, and say this is the z direction, say this is x and y. Yeah, usually we prefer to write z direction as the top one because the diagrams will mostly be like that, for better understanding. So you can say that this mark was like 5 or something. So say this is z equal to 5. This plane itself is z equal to 5, and obviously this is 0. So if you have to integrate it in cylindrical coordinates, the main idea here is what's called as a shadow. That means you just look from here, from the top. This is a very bad eye diagram, but still, please adjust. So when you look at it from the top, you're just gonna see a circle, and radius of it will be given, like obviously the equation of this cylinder will be given. So say x square plus y square equal to 4. That means ಮೇಲಿಂದ ನೋಡಿದಾಗ ಇದರ equation, it's gonna look like a circle, and that circle ka equation will be the same. Y square equal to 2 square basically, and so radius is 2, and radius varies from 0, and from 0 it goes on and varies till r equal to 2, 0 to 2. And what about the angle theta? Obviously one full round hakate andre theta will be 0 to 2 pi. And now one more factor we have, which is z. So z is basically like a function. You can treat, you should treat it as a function. In this case, the value of z varies from z equal to 0 up until z equal to 5. So z goes from 0 to 5. That's it. These are the limits. You have to put it in the integral they've given. Usually it's gonna be like what, dx dy dz only. Just put it and get the answer. And coming to spherical, which is a bit difficult to understand, at least I found it difficult to understand. Let me try simplifying it. For now, to simplify stuff, just straight up remember these, okay? Because I don't think we have time for derivation at this point. So once you remember this, you should be good to make the substitutions, but I'll still like tell you the main idea behind it. So for example, you can take, this is a sphere, okay? It's in 3D, it's not just a bare circle. So this is obviously gonna be split up into 8 octants. I mean, we can split this into 8 octants, and each of it is gonna be like this part. I don't know what this is called, but yeah, you have like 8 into these to make one sphere. And usually if they specify it's in one octant, that means they're referring to this part. And this part, graphically, you can basically, any point on this, you can represent it using these 3 parameters, that is rho, theta and phi. Whereas here it was just r, theta and z. Like one point, you can any point, like you can represent it using this. Here any point you can represent it using these 3 parameters. So yeah, here rho is basically like the length vector in simple terms. Then theta is like, I would say, I'll give it my own name, which is like 2D boss angle because it's just easy to understand. I'll tell you why. And then phi is just like, I think it's called lateral angle. I'm sorry if I'm wrong, but I think you'll get to know the visualization when I teach it. So yeah, it's like, consider that part I told you. Now you have obviously like 3 parameters to define, and wait, let me just redraw this. Yeah, I feel this much better. Yeah. So now from this point, this is in 3D. Okay, this is again that one part we were talking about, this one part. So here to here, like basically assume that you have, like, say you have an orange and you're in the center of it, and just cut it and make it into 1/8 of a piece. You have that one part of the orange. Now it's gonna be traced back to some origin over here, origin, and ಇಲ್ಲಿ origin ಇಂದ ಈ surface ವರ್ಗೂ, like till that outermost peel of that orange, whatever distance is there, I'd call that row. So you have your row defined, and now we have to define what is row is defined. We have to tell about what is theta and phi. So phi is basically what angle it makes from this axis. So yeah, let me just give you a very good example. Say you have a cone, and obviously r will depend, like it just goes till here, like, because that's the radius vector, and here that's where the length would lead you to, and the angle is basically from this axis till this slope. I'll show you I'll show you a video which will definitely clear stuff up, and this is what I call it as phi. And theta is, again, why did I call it 2D boss angle? Because in 2D I feel that it controls everything. So it's like, once you look at it from the top, theta is gonna tell you how much angle it scraped in 2D. Like when you view it from 2D, how much angle you think it's gonna scrape. That's what like are the limits for theta. So yeah, it will be mostly easy to identify theta, and even in this case as well as in cylindrical, it's just that you have to have a look from the top, and you have to see how the diagram is, or how that curve is actually being presented in 3D. So yeah, I think that should be good for that. I think for now this much of theory should be decent enough for, like, basic understanding. I think it's now better to just start off the classwork problems and build upon the concepts and learn from the classwork problems only. So yeah, classwork problems, be ready, we're coming for you. So let me give you a simple analogy on spherical coordinates. So assume that green color book is the target, and I have a laser pointer, or I have a gun here. So the 2D boss angle I was talking about, theta, it's basically my rotation. So to aim to that, I'll have to first rotate this much. And this rotation, what I'm doing, assume that there is a imaginary measurer here, and there is here, it's like theta angle. And after that, I have to bend my arm here, like this. And you see this angle, that is going to be your phi. So theta, phi, I targeted. Now I have to shoot the bullet. And to shoot the bullet, I have to, obviously, it has some length. Like, to reach that book, there is some length. So the length from here to that book, that is basically your row. Just a small note, I would want to cover these topics when I'm solving the classwork problems itself. Otherwise, it's simply going to take time, and it's just like simple formulas and integrating based on them. So yeah, I think we can pass for now, and we'll come back later. So guys, let's get it. Let's start classwork problems of unit 1. And moving to our first question, 0 to 1, 0 to 2, 0 to 1, 0 to 2, x cube plus y cube dx dy. Let me see if I've written right. Okay, so yeah, what you want to do is just you can see it's constant limits. So, and this is not functions in multiplication form, so just split it. Don't yes guys, so let us start with classwork problems. So yeah, first question, what's it? 0 to 1, 0 to 2. Okay. 0 to 1, 0 to 2, x cube plus y cube dx dy. Have I written it? Yeah, fine. So let us, this is a pretty simple question. What you do is just first integrate with respect to x, and the function you get, integrate that with respect to y. So you have 0 to 1, and x cube with dx is just x power 4 by 4 plus y cube is independent of x, so just uh, pull it out. Then you have 0 to 2, 0 to 2, and then you have whole integration with respect to dy. And now 0 to 1, 16 by 4 is just 4, minus 0 is ignore that, plus 2y cube dy. This is just 0 to 1, 4 dy is what, 4y. I directly integrate, never mind. 4y 0 to 1 plus 2 into y power 4 by 4. Limits are 0 to 1, so this is just 4 to 1 plus y power 4 is 1 by 2. This is just 8 plus 1 by 2, which is 9 by 2. What's the answer? 7 by 2. Maybe I think ours is correct, so you just change it to 9 by 2. Fine, let's go to the next question. Let us number these so that we have a track. 0 1, okay. 0 to 1, 0 to 1, dx dy, 1 minus x square, 1 minus y square, dx dy. Fine. So for this, what we do is, you can see that the terms are in multiplication form, so we can split them into their corresponding these terms, these are in multiplication form, so we can split them into the corresponding differentials. So this is just going to be 0 to 1, dx by square root 1 minus x square, dy by square root of 1 minus y square. And if you remember the integration 0 to 1, if you remember, this is just a formula for sine inverse. So this is going to be sine inverse x with the limits 0 to 1. This is sine inverse y 0 to 1. This is just sine inverse 1. We'll just do it manually, in the mind. This is just sine inverse 1 minus sine inverse 0 squared, because this is also the same thing. This is just pi by 2 whole square, pi square by 4. Perfect. Okay, third one is 0 to 2, 0 to 4 minus x square, x square y dy dx, I guess. X square y dy dx, yes. So for this as well, we can just split them to the corresponding terms. Here one thing to note is that we have 0 to 2 and we have 0 to 4 minus x square. As this has an x term, this must be y equal to this, and this is x equal to this. So we have x square y dy dx. So just split it and you get x square dx 0 to 2, and you have 0 selector 4 minus x square y dy. So this is x cube by 3, 0 2. This is what? Y square by 2. Oh wait, no, I messed up. You can't split it, my bad. Okay, never mind, let's just trim that. So yeah, this is this third question. Here we can tell that it's 0 to 2, then you have 0 to 4 minus x square. So here, as this part is a function of x, that means it has to be called as y. This has to be y, because x, if you write x equal to function of x, like if you do x equal to square root of 4 minus x square, it's just, it doesn't make sense, right? So because you're integrating it with respect to x, and ulta you're substituting the value of x again. So this has to be y. So you can't obviously split them. You'll have to integrate this part first, and then the function you get, you have to integrate that with respect to x. So first we'll be integrating with respect to y. So 0 to 2, x square is just independent of that. You have y square by 2, and the limits you're gonna put are gonna be 0 and 4 minus x square, and you have dx. So 0 to 2 square, this is just 4 minus x square by 2 dx, and this is 1, 2 comes out, 0 to 2, 4x square minus x power 4 dx, and this is just half into 4x cube by 3 minus x power 5 by 5, and the limits are 0 to 2. So what is this? Half into 4 into 8 by 3, 4 into 8 by 3 minus what is that? X power 5, 2 power 5 by 5, fine, minus, is it just 0? Yeah, 0, never mind. So it's just half into 3 minus 32 by 5. And this is wait, I have my calculator here. I'm lazy to do it by hand. Never mind, I'll do it by hand. So 32 into 5. Never mind. This is just gonna be 16 by 2, and this is gonna be 2 by 15. 16 by 15. Oh, I messed up somewhere. Oh yeah. This is 1 by 2 into 32 into, this is, I just took it outside, this is gonna be 2 by 15. This is gonna get cancelled. So this is just 32 by 15. And am I right? Yep. So now the fourth one. 1 4 is okay. 1 4 0 square 4 minus x, xy dy dx. All right. So for this, it's the same logic again. There's hardly any difference in the question. This is gonna be, no matter, I'll write it here. 1 to 4, 0 to 4 minus x, this has to be y, and I know that you know why it should be y. So xy dy dx. So madlu y respect to the integrate marna, that is gonna be 1 to 4. X is independent, y square by 2, 0 4, oh sorry, 0 4 minus x dx, 1 से लेकर 4 x this is going to be 4 minus x by 2 dx. This is half will come outside, 1 4 4x minus x square, half into 4 into x square by 2 minus x cube by 3, and just put the limits 1 and 4. This is gonna be half into 14, right? 14 by 2 is 8, 32 minus 4 3 is 64, 64 by 3 minus 1 is just 2 minus 1 by 3, and this should be 32 times 3 is just 96. Okay, half into 96 minus 64 by 3 minus 6 minus 1 by 3 half into what's 96 minus 64. Okay, 32 minus 5 by 3, which is just 27 by 6. Oh, never mind. This can be simplified. 3 9 by 9 by 2. Yeah. Okay. Next one is 1 0 x root x. This is the fifth one. 0 से लेकर 1 x root x, x square plus y square dy dx, and yeah, exact same logic. This is 0 to 1, y equal to x से लेकर y equal to root x, and x square plus y square dy dx, 0 to 1, then x square, this is just going to be y plus y cube by 3, put in the limits, x root x, integrate with respect to dx, and 0 to 1, x square root x plus this is going to be x 3 by 2 by 3 minus x cube plus x cube by 3. Be really careful about these negative signs because they mess you up so bad, you know. And what is this? 0 to 1, this is also 1 by 2, so x power 5 by 2 plus x power 3 by 2 by 3, and this is 3x 4x cube by 3, all of this with respect to dx, and this is x power 7 by 2 by 2 7 plus x power 5 by 2, you have 3, you have 2, you have 5, and then minus 4 x bar 4 by into 4, this is just gonna get cancelled, and put in the limits 0 to 1. This should just give you oh wait, I just realized. This should be 7, this should be 2. 3 into 5, 2. So this should be 2 by 7 plus, you're putting x as 1, plus 1, sorry, plus 2 by 15 minus 1 by 3. And this is what? Let me just use a calculator. This is 9 by 105, which is just 3 by 35. Are we right? Let's go. Where R is a region bounded by the lines. Oh yeah, this is interesting. We can use Jacobian and make it so much more simpler. I'll tell you how. So region R, x plus y, okay. And they told R is what? Bounded by lines. X equal to 0, x equal to 2, okay. X equal to 2, x equal to y, x equal to y plus 2. Alright. So wait, the first thing about this is has to be, let's just draw this to get a really good idea. So x is 0 is basically already drawn. X equal to 2, okay. X equal to y, x equal to y plus 2. So put x as 0, you get y, yeah, you put this, you get minus 2. Oh no, never mind. Wait, oh my bad, it's y equal to x plus 2. This happened in the exam, I would have felt so bad. Yeah. Now I recall the question from class notes. So yeah, when you put x as 0, you get y equal to 2, and you're gonna get this. Yeah, so our goal right now is to find the area between all these curves, between this one, and this one. So for that, yeah, this is basically the curve. For that, what you would do traditionally is take horizontal or vertical strips, but that's too lengthy. See, if you take horizontal strip, it's a bit like fine, manageable, but there's a better method. So like, rather than horizontal or vertical strips, use concept of Jacobian, or basically use concept of, I would say, like substitution, I guess. So see, the smart move here is basically the core logic of it is not to take strips horizontally like this. Rather, we should take strips which are tilted at this angle itself, so that if we have this strip, then we can just add it over here and continuously, rather than the strip being fully straight. It should, if this is not the strip we're considering something which is like something slanted, so that one iteration of it through this would suffice to cover this entire length. So that's the smart move we are doing here. And for that, what we can do is, let's just assume, right, smart move is just, we'll assume, say, y minus x equal to u, and basically we're defining the boundary values, and let us take another variable v equal to x. Yeah, I think this should do. So now what you have is, you have the four yeah. So the smart move we are doing right now is, just let us consider y minus x as u. By doing so, basically we are telling x is analogous to u and y is analogous to v. And by making this substitution, the reason behind the substitution is because we have y equal to x and y equal to x plus 2. So basically you can see that y minus x is always some constant, and that's why we took it as u. By doing this, we'll have we'll be having, like, u will vary from when y is equal to x. See, when y equal to x, u is just 0, and when y equal to x plus 2, u is 2. So we got the limits for u. Now we just need for y or v also. So let us just keep v as x. This is the substitution we're making, by the way. By doing this, we'll just have oh, and by the way, this is just 2. So we'll have, when x is 0, v is 0, x is 2, v is 2. So yeah, and surprisingly, the graph, it just becomes u and v. So u equal to 0, and then we had what? U equal to 2, and then v equal to 0, select a 2. V is obviously 0 here, and v equal to 2. See, it just became a square, and this is far more simpler to integrate. And let's just put that back in the question. So we have x plus y in the question. The main part is x plus y, and based on the substitutions we took, x is v, and y is u plus x. u plus x, whereas x is, again we've taken it as v, so v plus u plus v, which is 2v plus u. And if you integrate this, and what are the limits, by the way? You had 0 to 2, 0 to 2, 2v plus u. And if you find the Jacobian, you'll get the Jacobian as 1, because you can clearly tell that there, if you do that in your mind, the Jacobian is going to be 1, because like if you partially differentiate, you're gonna end up with 1. And you might wonder what's the, oh wait, x plus y dy dx. Okay, fine, dy dx. And yeah, we have taken dv as this one, so dv is just going to be dx, so we'll prefer to keep it at the end. So first is we'll have to take du and then dv. This is what is a better form. And this is just going to be 2uv plus u square by 2, put in 0 and 2, dv. 4v plus 2 dv. I'll directly do it, never mind. This is just 4v square by 2 plus 2v, put 0 to 2, this is 2v square, 4, 8 plus 4, which is 12. And are we right? Let's go. Okay, what's the next one? Region R is bounded by the parabolas y square equal to x, x equal to y. So we have, question number 7. This is, have I marked it? 6, okay. X square equal to y, y square equal to x. Then show that xy, x plus y. Show that xy, x plus y, integration over some region, dx dy, dx dy equal to 3 by 28. 3 by 28, yep. Okay, so the thing with integration is you have to always first start with considering the limits of integration. That is going to simplify stuff. Anyways, I've told region R, so you'll anyways have to construct the region and find the limits. So y equal to x square is just this one. And if you're confused as to what is x square equal to y, you can just, by logic, you can tell it's ulta, or yeah, I think that much of logical sense is enough. So yeah, this is another one. So you have y equal to x square, and you have x square equal to y, x and y, and we have to find the region within this. So that should be this. Here we have two options, either to take vertical or horizontal. So let me just take horizontal. So let's take a horizontal strip. So if we take horizontal strip, we have to tell the starting and ending values of x. Oh yeah, and what is the value of y? This is 0. And what is the value over here? It's basically the point of intersection, and point of intersection is just going to be x equal to, oh wait, my bad, This is x equal to x square, x equal to y square. Yeah. So the intersection is gonna be x equal to x power 4 and x power 4 minus x equal to 0, x into x cube minus 1 equal to 0. For now, yeah, this point you can easily tell that it is x equal to 1. This point is x equal to 1. So when you put 1, you're gonna get 1, obviously. So yeah, you know the values of x and y. X1 and x2. If you've taken you also know y1 and y2. But if you're taking horizontal strip, your x value is gonna vary from the first graph to the second graph. So the first graph is x the value y square ಇದೆ ಅಲ್ಲಿ, and it's going until the second graph. Second graph ಅಲ್ಲಿ x value ಏನಿದೆ, you have to take root y. And you might be like, why are we not taking plus minus root 5? Here it is in the positive side, like the intersecting area is in the positive quadrant, so we're just taking it as plus y. And what are the limits for y, you may ask? Y is going from 0 to 1. That's it. 0 se lekar 1. And you know the rule of thumb, the constant limits will be outside. So 0, 1 and y square in the hidu, it's going to go root y. Sometimes if you get confused and you say you interchange and write it as root y to y square, it's fine. It's not a big deal, because at the end you're just going to get a negative. You're going to get the answer which is negated, and you'll get to know area is not negative, so you're going to take the modulus of that and you'll be good. So what was the function? Xy into x plus y. Oh yeah, xy into x plus y is just x square y plus xy square d. This is the function. This is x, so you must take dx here, not dy. This is 0 to 1, x cube by 3y plus x square y square by 2 y square root y. This is just going to be 0 to 1 y 3 by 2 into y by 3 plus y cube by 2 minus y square, right? 5, no, this is gonna be what, 6 and 7, y power 7 by 3 plus this is gonna be 4 and 6, y power 6 by 2. Take this, and then you can do dy. This is what, integration 0 to 1 y power 5 by 2 y power 5 by 2 plus y power 3 by 2 y power 3 by 2 minus y power 7. Yeah, this is standard. Minus y power 7 plus y power 6. What was this? By 3 by 2. By 3 and minus by 2. Am I right? Yeah. And then here you have dy. So 0 to 1 is going to be 2 by 7 y power 7 by 2 by 3 plus y power 4 by 8 minus y power 8 by 3 into 8 minus y power 7 by 14. No mind, yeah. This is just 0 to 1. So what do we have? 1, right? Okay. 2 by 21 plus 1 by 8 minus 1 by 24 minus 1 by 14. And I think they should give you, again I'm using the calculator, 2 by 21 plus 1 by 8 minus 1 by 24 minus 1 by 14. Yeah, that is 3 by 28. And what's the answer? Let's go. A pyramid is bounded by 3 coordinate planes and the plane. Okay, wait. So here they've told us to use double integration, but you'll be like, wait, there's a third variable. So in that case, wait, let me just write it down. So note. So in case a third variable pops up in double integral, consider that as the function. So in this case, that given z, and we're not accustomed to z in double integral. So yeah, x plus 2y plus 3z. X plus 2y plus 3z equal to 6, I guess. 3 coordinate planes andre, that means you must also take x equal to 0, y equal to 0, equal to 0. So what did I tell you? You have to take the third variable as a function. That means you have to take z as a function. So 6 minus x minus 2y by 3. And you'll be like, how do I take limits if there is a third variable? It's very simple. Just take the shadow. Take the shadow. And then so in this case, what taking the shadow means just finding the intersection of z, or viewing it from the top. So you have z equal to 0, so just put it in that, and you're going to get x plus 2y equal to 6. And if you plot this, what do we get? At x equal to 0 you have y equal to 3, at y equal to 0 you have x equal to 6. Yeah, so this is what you have. And again, here you can find the limits, take the limits. Let me just take a vertical strip. So it's going to be y is varying from 0 to this function, or this line which is governing the function, which is 6 minus x by 2, and x is varying from 0, and what is this point? 6. So x varies from 0 to 6. Just put it in the integral, and obviously y will go here. So 0 in the hidudu, it's going to go till 6 minus x by 2. Y is 0 to 6. And yeah, here they didn't give about the integral, right? So you have to find, for finding the volume, the general formula is dx dy dz, and that's why you have to take it's either like dx dy dz triple integral, or it is double integral f of x comma y dx dy. General formula for volume. So yeah, in this case, what do we have? We have to take the function of z, obviously. So we have 6 minus x minus 2y by 3, and what should we take? Dy dx, because y. So this is gonna be 1 by 3 is gonna come out, and you have 0 to 6, you have 0 to 3 minus x by 2. Oh sorry, not 3 minus x, 6 minus x. Six minus x by 2, and yeah, and then you have the function 6 minus x minus 2y dy dx. Yeah, 1 by 3, 0 to x. This is just 6y minus 6xy minus y square. 0, 6 minus x by 2 dx. You're gonna get 1 by 3, 0 to x, 0 to 6, and 3 into 6 minus x minus 3x, 6 minus x minus 6 minus x square by 2 dx. And oh wait, yeah, we can just take 6 minus x common. Just realize 0 to 6, 6 minus x, 3 minus 3x minus 6 minus x by 2 dx, obviously. 3, 0, 6 minus x. What is this gonna be? 6 minus 6x. Oh wait, this is gonna be minus is gonna be here. So minus 6x, sorry, minus 6 plus x by 2 dx. I think we can just trim it up till here. So yeah, what do we have? We have 6 minus x, which is like independent of y. So we just write it as 0 to 6, 0 to 3 minus x by 2. Yeah, and then we have 6 minus x minus 2y dy dx. 1 by 3, 0 to x, so 0 to 6, 6 minus x into x, sorry, into y minus y square, and put in the values of 0. Okay, you know what, let's just consider it as 6 minus x by 2 itself, and then dx. So this is going to be 1 by 3, 6 minus x whole square by 2 minus 6 minus x whole square. We have integration 0 to 6 dx. 1 by 6, 6 minus x whole square dx, 0 to 6. And this is just, how do we do this? 1 by 6, 0 to 6, 6 minus x whole square dx. Just take 6 minus x as t. You know what, you can just put this in the calculator and then you can get the answer, but let me just do it manually. Which, if I take this as t, I have dt as minus dx. So 1 by 6, and limits are going to be what? When x is 0, t is 6, x is 6, t is 0. So this minus is gonna effectively reverse it. So we'll have 0 to 6 t square dt, 1 by 6 t cube by 3, put in 0 and 6. This is gonna be 18 And 6 cube is what? 6 into 36. 6, 3, 3, 1, 1, 2. Is it 12? Okay, it's not 12, it's 6. What? What's the mistake I did? Yeah, the only change here was here it was 4. So this is gonna be 1 by 12. And once you get 1 by 12, yeah, 1 by 1 by 12, 1 by 12, 1 by 2. So it's just equal to 6. Well, 3s are 36. 6 into 36. Cancel. So yeah. Now let's go to the 9th one. Zero, 1, 3 by 3. 0, 1, 3 by 3. E power x square dx dy, and you have to change the order of integration. So to do this, we'll have to first draw the limits and then take the opposite step. So you have x equal to 3y, x equal to 3, y equal to 0, y equal to 1. So x equal to 3 is this, x equal to 3y is 0 and this, right? Yeah, passing through the origin. So 3, this is gonna be 6, because at x equal to 3 this is gonna be 9. And y equal to 0, y equal to 1. So at y equal to 1, this is gonna be 3. Oh wait, my bad. So yeah, when you plot this, you get x equal to 3, x equal to 3y is like a line passing through the origin. So when x equal to 3, the value of y is 1, and yeah, that's basically y equal to 1 as well. Y equal to 1, this is x, this is y, x equal to 3y, and x equal to 3. And the area they've given is 3y से लेकर 3. So x varies from 3y and goes till 3. This is the strip they have taken. And our job is to take this strip now. So the corresponding changes will just be y goes from 0 से लेकर x by 3. And x will, because 0, y is 0, and this is y equal to x by 3, and x value will be 0 से लेकर 3, and the integration will be what, 0 to 3, and y is 0 to x by 3 e power x square dx dy, and my bad, it's not dx dy, it's dy dx, and yeah, now x square is just independent of y, so we can just directly integrate 0 to 3 e power x square, and y would just dy would be y, put the limits as 0 and x by 3, integrate this with respect to x, 0 to 3 you get x into e power x square by 3 dx, take 3 outside, 0 to 3 x power x into e power x square dx, just take e power x square as t, so you have 2x e power x square using chain rule, dx equal to dt, as simple as that. So when x equal to 0, t equal to 1, because e power 0 is 1, and then when x equal to 3, t is just e power 9, so you have 1 by 3 into 0 से लेकर e power 9, and this is what, all this stuff is oh yeah, so your x e power x square minus x square dx is just dt by 2, so you have dt by 2, let me just bring this a bit down, and this is just 1 by 6, and e power 9 minus e power 0, which is 1 by 6 e power 9 minus 1, and are we right? Let's go. The next one is e power minus y, 10th one I guess. Let's go. 0 से लेकर infinity, x से लेकर infinity, e power minus y by y dy dx, change order, fine. So in this, the same thing, this is I think much simpler. You just have to take y equal to x, y equal to infinity, I mean by y equal to infinity we mean y goes towards positive infinity, and then same thing, x0 and x goes till infinity, yeah, you have y equal to x, and again you might be wondering whether to take this part or whether to take this part. So they've told y goes from x से लेकर infinity, so it's not 0 to x, it is x to infinity, so that means this entire region, and they had taken x to infinity, y equal to x to infinity, so that means they've taken the strips like this, and we need to take the strips which are like this, and for that what do we have to change? We have to take x varies from, this is 0, x is 0, and here x is just y, so we have x varies from 0 to y, and y varies from 0 से लेकर infinity, 0 to infinity, and what do you have? You have again remember a constant limit outside, 0 to y, and you have e power minus y, let that be as it is, e power minus y by y dy dx ididdu, we have to make it as dx dy. So the magic here is just gonna be treated as independent. You'll have x 0 y dy. You understood, right? Like this part is just independent of x, so it's like just k into x power 0. Integration of this is just going to be k x power 1. That's it. So this will be 0 to infinity e power minus y by y into y dy. Cancel. Integration e power minus y by minus 1. Put the limits as 0 and infinity. You know the graph for e power minus y is just like this, y equal to e power minus y. So they're asking at what? Infinity and 0. At infinity, e power minus y tends to 0, and at 0 it's just 1. So we have minus of 0 minus 1, just plus 1. Let's go. Alright, let's move on to the 11th one. That's it. 0 to 3. Half 9 minus x square and 9 minus x square. X dy dx. Okay. X dy dx. Again, change order. Changing the order. So yeah, again the arm. Oh wait. Yeah, our main step, the starting step, is just writing down the limits. So we have y equal to half 9 minus x square, y equal to square root of 9 minus x square. Fine, so we know that this is a sphere. Oh wait, my bad, not a sphere, a circle. And what about this? This is like x square plus y square equal to 9. So like 1 by 2, 1 by 2. This is what, like an ellipse. And you just have to plot it, and we know the circle is just going to be centered at the origin with radius 9, and the ellipse we have to find out. Wait, so when you put x as 0, you get 3 by 2. Y as 0, you get x as, what do you get? Y as 0, so you get it as 3. Right, y equal to 0, yeah, you get it as plus minus 3. So that means it goes like this, something like this. It's not that sharp. Yeah, 3 by 2, this is 3, this is plus 3, this is minus 3, and what was the question? Yeah, evaluate. And again, you might be wondering whether the region is this, whether it is this. That all of that is clear from the question they've given. They're like telling ellipse in the circle ವರ್ಗೂ ಹೋಗುವಂತ. ಸೊ ಎಲಿಪ್ಸ್ ಇಲ್ಲಿದೆ, ಸರ್ಕಲ್ ಇಲ್ಲಿದೆ. ಸೊ ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಹೋಗೋಕ್ಕೆ ಒಂದೇ ದಾರಿ ಇರೋದು, ದಟ್ ಈಸ್ ಲೈಕ್ ದಿಸ್, ಆರ್ ಪ್ರಾಬ್ಲಿ ಲೈಕ್ ದಿಸ್ ಆಲ್ಸೋ, ಬಟ್ ದೇ ವುಡ್ ಹ್ಯಾವ್ ಟೋಲ್ಡ್ 0 to 3, right? So it's like 0 to 3 you're going. And yeah, you can't go like this because it's not negative. They've only told positive part of the ellipse. So this is the region we're looking for. This is a very good question. I'll tell you why. Yeah. So let's take horizontal strip. Fine, we'll take a horizontal strip here. What's the catch? Fine, you'll be like succeeding it till here, and at this point, yeah, what exactly was a strip? Let's revise again. It's basically you going from one function to another function, and in this case, let us call this region 1, or the part above this yellow line. In that, you're going from x equal to 0 से लेकर x equal to the equation of the circle, which is 9 minus y square. Whereas here, if you take a strip here, you're going from x equal to 9 minus 2y square, basically from the ellipse to the circle. So you can't solve this with just one. You can't solve it with just one integration. You have to consider it as two regions and you have to add them. So basically, your region 1 is going to be x varies from 0 to 9 minus y square. Oh wait, my bad. Yeah, this is square root here also. And y varies from this one, 0 to 3. Oh wait, no. Sorry. In region 1, it goes from 3 by 2 to 3. This part. 3 by 2 से लेकर 3. And then in region 2, this part, it goes from 0 to 3 by 2. Y goes from 0 to 3 by 2. X goes from square root 9 minus 2y square से लेकर 9 minus y square. So your answer would just be integral 3 by 2. No, let's take it in 0 to 3 by 2. And wait, I think I made a small mistake. Did I? No, I think we're good. Yeah, so where was I? Yeah, we're going from 9 minus 2y square to 9 minus y square, and this is just the same function, x dy dx plus 3 by 2 3, and here we're going from 0 to 9 minus y square, x dy dx. I'm sorry, you might hate me for this, but it's just gonna take too long for me to solve the complete question. So yeah, just please bear with me and just do this calculation. I'm also referring to one of the solutions, and yeah, so far it's correct. It's so far, wait, it's not correct. It is 4y square. Yeah, now I think it's correct. So just solve it, and the answer we should be getting is 9 by 2. Wait, what? Yeah, the solution here says something else, but Yeah, I think the answer is 9 by 2. Yeah, so the answer 9 by 2 is correct. So yeah, 9 by 2 is indeed correct, and let's move on to the 12th one. In the PDF, I'll finish this up and I'll send it to you, so that'll be like a completed one. I won't just leave it here. But yeah, at least for the video tutorial, I'm sorry, I'll just have to leave it. So yeah, for the 12th one, 0 to 4a, x square by 4a, and yep, change order of integration. So in this, again, our same procedure, write y and x, like just plot them. Root x is 0, so like x is 4a, and if you see, it's just x square equal to 4ay and y square equal to 4ax. So it's similar to that parable, y equal to x square and x equal to y square curve. So this is like this, and this one is like this. So here again we have to consider strips. Let us just take a horizontal strip. And what is this? Again, for intersection, it's like you can use common sense and find out. And in this case, it's gonna be what? X is y square, so y power 4 by okay, yeah, so these points, if you find the intersection, it's gonna be this is gonna be 4a, and this is gonna be 2a, I think. Yeah, when you put 2a, you're gonna get 4a square equal to 4a. No, sorry, I have to put So this is just one parabola like this and the other parabola like this, and we have to find this region. Again, if you're confused about which region to integrate upon, just see from where to from which function to which function it's leading. So let's take horizontal strip, and this point of intersection is, if you solve it, it's just going to be 4a and 4a. So our limits are going to be x goes from this function to this function, that is y square by 4a to 2 root ay, and the y value goes from 0 to 4a. So our integral just becomes 0 to 4a, and why 0 to 4a? Because this is 0 and we have to take the strip like this, and 2 root ay dx dy. Yeah, this is 2 root, wait, what? Y square by 4a, my bad. This is 2 root ay minus y square by 4a dy, and this goes from 0 to 4a. 2 root a, and integration of y power 1 by 2 is y power 3 by 2, 2 by 3, and then in this you put 4a, minus 1 by 4a into y square is just y cube by 3, put 0 and 4a, you get 2 root a, 2 power 3 by 3 minus 1 by 4a into 64a cube by 3. This is just 32 a power 3 by 2 plus 1 by 2 minus 16 a square by 3, that is 32a square minus 16a square by 3, that is 16a square by 3 should be our answer. Let's go. Now let's go to the 13th one. Zero 1 x square 2 minus x. 0 1 x square 2 minus x, xy dy dx, xy dy dx, same thing. So we just do y equal to x square, y equal to 2 minus x, and x equal to 0, x equal to 1, plot it, you get like this. You have a parabola, and then you have a line y equal to 2 minus x, so at x equal to 0 it is here, and at y equal to 0 it's at here. Yeah, just make it here. Y equal to 2 minus x, y equal to x square. So now they've told us to integrate from x square to 2 minus x. So x square to 2 minus x is this one to this one, and they've told x equal to 0 and x equal to 1 as well. This is x equal to 1. So it is just this part which we are integrating. So again the same thing, if you take horizontal strip, this part is gonna cut you off because you're going from x equal to 0 and you're going to this function, that is y, sorry, you're going to 2 minus y, whereas this is in R1, whereas in R2 you're going from x equal to 0 to the equation of the parabola, so root y. So that's why you have to just add the two regions. This is just, and y value, what is the y value in each case? So y is gonna be what is this? This is 1 1. So y is gonna be 1 and this is 2, 1 to 2. Y will be 0 to 1, 0 to 1, 0 to root y, x y dx dy. Yeah, note it's dx dy, not dy dx. Plus 1 to 2 integral 0 to 2 minus y xy dx dy. And this is just 0 to 1 y into x square by 2, then 0 root y dy plus 1 to 2 y into x square by 2, put in 0 2 minus y dy, and after that you solve and you're gonna get 3 by 8. Yeah, you're gonna get 3 by 8. So please trust me and just do the calculation. So yeah, let's do the 14th one. It's talking about Jacobian. Explain what is Jacobian. I don't think they'll ask it in the exam, but you can still explain. I'm sure you can kind of manage. So they're like x is r cos theta, y is r sin theta, and z is z. Okay. And find the Jacobian of transformation from Cartesian coordinates to cylindrical. Okay, fine. They've given 3 parameters, so we'll have to use the formula which has obviously 3 equations. Just dou x with respect to dou r, dou x with respect to dou theta, dou x with respect to z, dou y dou r, dou y dou theta, dou y dou z, dou z dou r, dou z dou theta, dou z dou z. Oops. Yeah, and if you just quickly do it, this is gonna be cos theta, because it is differentiating with respect, only with respect to r, and minus r sin theta, 0. This should also be 0. This is sin theta, r cos theta. Z is not dependent on this. 0 0. This is gonna be 1. So property of determinant, just expand along this row and column. So it's just gonna be if you evaluate, it's just gonna be what? R cos square theta minus r sin square theta. So r into cos square theta plus sin square theta. So Jacobian is just gonna be r. So this thing is also done. So now coming to 15th one, transform the integral. Oh yeah, that was a misprint by the way. This is the correct one, into polar coordinates. So 0 0 1 1 f of x comma y dx dy to polar. So again the fundamentals still remain the exact same. X equal to 0, x equal to 1, y equal to 1. And yeah, we gotta convert this to polar. So what are the main things we need? Are r and theta. So r, we'll talk about that, but what about theta? The only area we are required is this one. So theta, logically, it is screaming and telling it 0 to pi by 2. And what about r? So you'll tell like, so r goes from, say, this point you consider, it goes all the way till here. And if it one thing which covers the entire picture is an equation. So for r, we'll have to split it, obviously, because here this curve follows a different equation, this curve, like this part, follows a different equation, and this one also follows a different equation. So that's why let's just split it up into the part where it's actually getting broken. So let's take this as region 1, let's take this as region 2, and this is what, y equal to 1, x equal to 1. So this is our radius, or our vector for that matter. So it's gonna be, when it is over here, it's gonna be x equal to 1. It's gonna be intersecting with x equal to 1, and x equal to 1 is basically what, r cos theta equal to 1. That means r is just secant theta. So in region 2, r goes from what? It goes from all the way 0, and the distance is 0, or yeah, the length of it is 0, and it goes to r equal to secant theta. And in the next case, y equal to 1 is just r sin theta. So in region 1, r goes from 0, same thing, it ಇಷ್ಟು ಸಣ್ಣದಿರುತ್ತೆ, ಅದಾದಮೇಲೆ ಇಲ್ಲಿವರೆಗೂ ಹೋಗುತ್ತೆ. r equal to 0 to r equal to cosecant theta. That's it. We just set up the integral, which is theta is anyways 0 to pi by 2, and here it's gonna split. This is pi by 4. So theta, when it is 0 to pi by 4, it is gonna be, in our case, it's gonna be region 2. That is r is gonna be 0 to secant theta, and what's the function? F of x comma y. Just put the substitution, r cos theta, r sin theta, and don't forget the Jacobian, which is r and dr d theta plus pi by 4 se lekar pi by 2, and this, in our case, it is region 1, my bad. So in our case, it's region 1, so it's gonna be r equal to 0 to cosecant theta, and same thing, f into r cos theta, r sin theta, r dr d theta. And yeah, if you verify, I think that's gonna be correct. See, 0 to pi by 4 jite secant theta ಇದೆ, ಇಲ್ಲಿದು 0 to pi by 4 secant theta na ಇದೆ. Yeah, so it is correct. Then moving to the 16th one, infinity, okay. Plus y square dx dy. Yeah, so in this case, that like use polar, and for this, if we are using polar, obviously we make the substitution, x equal to r cos theta, y equal to r sin theta. So it's just gonna be, yeah, again the limits are what, 0 to infinity here, and here I'm telling. So x goes from 0 to infinity, so does y. So this part is our region, and that is basically, in polar, that is theta is what? Pi by 2, and r is 0 to infinity. Just revising, r can't be negative. So yeah, so the limits are going to be 0 to pi by 2, and yeah, outer limit should be a constant. Here it's, in this case it doesn't matter because both of them are constant. And then what? E power minus r square into r dx, oh sorry, r is a Jacobian, dr d theta. You can use gamma functions and write it quickly, but you can also take e power minus r square as t and solve, and you get some answer. Or you can use gamma functions also, and the answer you should be getting, I think you'll get the right answer, don't worry. So yeah, it should be pi by 4. Let me just have a look once if, yeah, it in fact is pi by 4. It's gonna come to pi by 4. So let's go to the 17th one. Basically 001 x 2x minus x square dx dy. So you have to convert this to polar again. Whenever you see x square plus y square, your mind has to go to polar. In exam, it might not be sure that they're going to tell you to use polar. Your brain should be smart enough to identify it, and just you're going to save a lot of time. So here again the same old process: y equal to x, y equal to square root 2x minus x square, and x equal to 0, x equal to 1. What is this going to be? X square minus 2x plus y square equal to 0. This is just a circle. Yeah, it's just x minus 1 whole square plus y square equal to 1. That means it's gonna, the various graphs in this are gonna be like, you have a circle, oh wait, my bad, radius is 1, so it has to be around here. Remember, it's theta. Even if you basically, okay fine, ignore the markings, just draw it in Cartesian and just write the appropriate stuff in polar. So you have x minus 1, then you have y equal to x, which is like this, and what else do we have? X equal to 0 we have, and we need x equal to 1. This should technically pass through the center, but the diagram is a bit messed up. Yeah. Yes, this is still better, yeah. 1, this is 2, and x equal to 1. We needed this line, we needed y equal to x, and again, judging the conditions, it's like x to 2x, root 2x minus x square. So that's basically from x to root 2x minus x square. That is going to be this area. And yeah, so our job is not to find strips now, rather it's to find the intersection and actually measure the value of the angle and radius. So as this is y equal to x, the slope is 1, that means this is 45 degrees. So that means our theta must go from 45 degrees to the end, that is 90 degrees. Pi by 4 to pi by 2. Okay, fine, theta is sorted. Now what about radius? So the radius is obviously r equal to 0. And what's the upper limit? So from here it goes till this circle, and wait, it's basically like it's going like this, and everywhere it's touching is basically the equation of that circle. And what is the equation of that circle in polar? Okay, wait, let's write that in Cartesian. That's what they had given us, x square minus 2x, that stuff. Yeah, so that's basically like x square plus y square equal to 2x. We can write this as x square plus y square equal to 2x, and that is going to give us this is r square, and x is just 2 r cos theta. R and r cancels, so r is basically 2 cos theta, and that should be your limit. I'm sure many of you would have not understood why we took the intersection, because I was one amongst you guys who were like didn't understand during the initial phases. So see, anything we do about integration, that too in 2D and 3D, it's all about going from one function to another function. So in this case, we're going from one function to another function in terms of, like radially. So that means the radius is going from this function, or never mind, not this function, I mean it's 0, and it's going to some certain distance, and in this case that distance is tracing this path of the circle, and that path is defined by an equation, and it's just as simple as that. It's like start is mostly radius is going to be 0, not necessarily, but yeah, at least this cases so far the radius was 0, and it's going to end up at either a constant or either a function. In this case, it's, you can see radius here is different, radius is here is different. That's basically a function. And about why we are finding intersection, that's basically us equating the radius and getting a good like basically our equation was in terms of x and y, it was in Cartesian, but we want the equation in terms of r. So for that we solved this, and we got the upper limit for r. So yeah, that, and basically you write the integral as pi by 4 to pi by 2 and 0 to 2 cos theta and r square r d theta. You solve it and you're gonna get the answer as 3 pi by 8 minus 1. Okay, now let's move on to the next question. So xy dx dy over, the given region is sine 2 theta. Yeah, so this is the particular function, like sine 2 theta or sine n theta for that matter. If n is even, you have even petals. If it's odd petals. So in this case, the question they gave, it's sine 2 theta. So they've given us sine 2 theta, and talking about the actual question, it's xy dx dy and the region r, and where r is basically sine 2 theta. Okay, fine, sine 2 theta, and theta belongs to 0 to pi by 2, right? So knowing the graph, pay attention to this, please. It's the one we are going to be using right now. Like this. I did explain it in the starting of the video also, but yeah, just please ignore the diagram, it's very messed up. So it's just the positive, the like pi by 2 first quadrant ಅಷ್ಟೇ consider ಮಾಡಬೇಕು. So just ignore all these, and our main focus should only be on this dude right here. Theta is equal to 0, theta equal to pi by 2, and I told yeah, first thing is already sorted. We got the theta value already sorted. They had only given it to us. Just the problem, yeah, so theta is done, which is 0 to pi by 2. Now the thing with r is obviously it starts from 0. R is 0, that we got to know. And you guys tell me where it's going. This is an arbitrary point, arbitrary point, arbitrary point. So it is going to a function, or it's tracing this path, and this path can be denoted by an equation, and that equation is the one they gave, which is just sine 2 theta. And as that is sine 2 theta, oh yeah, it's already in terms of theta, so it's just sine 2 theta. You don't have to simplify it further. And it's just x is what? R cos theta, y is r sine theta, the Jacobian is r, dr d theta. Limits for r 0 to sine 2 theta, 0 to pi by 2. And upon solving this, you're gonna get 1 by 15. Let's see. Yep. Hey guys, so let's move on to the 19th one. Unlike others, the 19th one limits find out ಮಾಡೋದು ತುಂಬ ಈಸಿನೇ ಇದೆ. It's like the limits are like pretty simple. Minus infinity to infinity, and here also minus infinity to infinity. And a by x square plus y square plus a square 3 by 2, x square plus y square plus b square 1 by 2 dx dy. What I was telling was finding out the limits for polar, it's like pretty easy, but the main integration seems a bit lengthy. Okay, see, for the limits, I'm sure you all are smart enough by now to identify what the limits for theta and r are. Basically it's this entire region, like completely all the Cartesian plane. You know what it is? Just theta varying from, like, my bad, theta goes all the way up till 2 pi. Oof. Yeah, so theta goes all the way up till 2 pi, and radius goes from 0 to infinity, right? So yeah, never mind. So we have theta which goes from 0 to infinity, r which goes from 0 to infinity, theta which goes from 0 to 2 pi. So we have the limits, but the integration itself, I'll just tell you how to proceed. It's just that given this in class, okay, and I couldn't figure it out for like 5 to 10 minutes. I don't know why, but yeah, now it's interesting to solve it again. So yeah, you have r plus a square, oh my bad, r square plus a square 3 by 2 into r square plus b square. Oh wait, my bad, did I copy the question wrong? No, it's correct. This is 1 by 2, and yeah, Jacobian is necessary. Yeah, from here the main step here is to resolve all this mess by substitution, obviously. So what you got to do right now is you have to consider this part. as a thing to substitute. So basically 1 by square root r square plus a square, you have to consider it as t. By doing that, why we are particularly considering r square plus a square term, because we have a in the numerator, and as a is in the numerator, and even once we by chain rule, when we apply chain rule here, that a square is gonna become 2a upon chain rule. So that's why we use this term, and you have t. So from this you can find out what r square is. R square will be 1 by t square minus a square, and now once you differentiate, you're gonna basically get the equation as r square plus a square 2 into r dr equal to dt. So put the limits for, like, when r is equal to 0, you have t equal to 1 by a. R is infinity, you get t as 0, and no doubt theta is just independent, so that integration, like, once you put the limits for this, you're gonna have just it's gonna be 2 pi, and this a is gonna come out, and yeah, basically you solve it, and you take you replace this r square with the one we just, the equation we wrote, and you're gonna end up with a better looking equation, and you have to use substitution there again, which is a bit of a headache. And yeah, finally you do all the calculation, you're gonna get the answer as 2 pi by a plus b. But the main step is limits. Easy. First substitution was 1 by square root r square plus a square, you took that as t. Idadmele, the second substitution later you'll do. It's like you'll get some 1 plus second substitution, you'll get like 1 plus b square minus a square t square. You have to take this as u square. Don't ask me how. If I had more time, I would have explained, but yeah, for now it's just this much, and then solve. So yeah, you're gonna get 2 pi by a plus b or something. Correct. And so yeah, with that we're done with second integral. Let's just have a quick check. So satisfying to see the complete page text. Let's keep the satisfaction. We have like, we're almost half the way through. So yeah, 19th is done. Let's go to the 20th. From here the starting questions are easy, but then it becomes it goes a bit difficult. Don't worry, we'll go together, we'll finish this together. So 325 212 325 212. Oops, that was so small. xy square. Nah, it's not an integral. Oh my god, it looks like some what do you say, I don't know. 1252, I guess. Nah, xy square dz dy dx. Yeah, for this, as these are in multiplication term and they are like kind of individual, you can just, and yeah, I mean mainly the limits are independent of any other variable, you can just split them. And yeah, again, when you're splitting, it should be in the same order. Split in the same order. So once you do that, you'll get 2 5 dz 1 2 y square dy 2 3 dx. In integration, it's always inside to outside. Like, yeah, it is inside to outside. You solve this and you're gonna get the answer. Like, it's pretty simple. And in the exam, okay, like In the exam, when you are one step closer, just use your calculator, put in the formula, and it's gonna give you the result. That is more than enough. You don't have to further calculate it. So this is also done. Now what about 21st? Again, don't mind me, I'm just speeding through this because it's just calculation. I'll just tell you the main step, and if I just do the calculations, I'll be like time, like, waste of time. -1 1 0 z or z, you call it whatever. X minus z, x plus z. dx dz. Yeah, so in this it's like this. I like calling it as peeling an onion, because you go like layer by layer. So illy it is a function of y. Here, as you have, see, you have y here. Once you're done with y, you just, the business is done. You don't go back to y again. You go to the next integral, and here you had x, y, z. You just used y. So my bad. You had x, y, z. You used up y, so this is gone, and the next variable is z. So that means it has to be a function of x equal to, and here it's obviously z. Logically, if you think, you're substituting whatever answer you get here, you're putting the limit as z. So that means this function, whatever you're integrating it on, that has to be a function of z. So yeah, it's like, that's why it's like peeling an onion layer by layer. So for this, what you do is, it's pretty simple integration. Just open first layer and just integrate it with respect to what, y. Then put the limits. It's simple, okay? It's like pretty simple. And what's the answer you get? Answer is 0. Fine. Just verify the calculation, okay? I just told you the starting step. It's just you putting in like split dy dx dz inside this, and integrate with respect to dy first, then with respect to dx, and then dz. It's gonna be very lengthy, okay? It's like very lengthy. I remember that, and it's gonna take some time. So yeah, hello. So yeah, we're done with 50% of the questions. Let's grind the remaining ones. We'll finish it with a good efficiency. So yeah, 22nd, I'll tell you, this is very simple, very simple. So you have z equal to 0, z equal to 1 minus x square minus y square. You have y equal to 0, y equal to 1 minus x equal to 0, and x equal to 1. Here it's like everything is spoon fed for you, spoon fed to you. It's like x values they've given, y values they've given. I mean, limits of all of them are given. So it's just gonna be integral of x is what, 0. Oh yeah, I'll tell you. You have to start with z. My bad. So z is starts from 0 and goes to 1 minus x square minus y square. Then use the onion peeling logic. You go to z is done, so you go to y. So y goes from 0 to 1 minus x. Last layer of peeling it is 0 to 1. This is y, this is z, and what's the function? They haven't given, so it's just dz dy dx. This is pretty, yeah, that's it. It's like solved only. You just have to do the calculation, and you'll get the answer as v equal to 1 by 3. V, because it's volume. It's like meter cube. That's it. So this thing is also done. So yeah, from here is where another core part of the chapter starts. I know it already, the video I'm sure is already going to be so long, maybe an hour or two already into the chapter, and then I'm telling that this is the core part. Yeah, I guess this unit is like that. uh, like, let's just have a small discussion on the units, just to kind of have some relief. Okay, so you have unit 1, which is integration. You have unit 2, which is probability. Unit 3, which is Laplace transform and inverse Laplace. And then you have unit 4, which is Fourier series and Fourier transform. Okay, so integration, again we have what? 2D, then 3D, and applications. You saw 2D with like enough practice, you can master it. In 3D, it's just limits, you have to get it right, plus long calculations. Applications, it's like the initial step, you have to get it right. The initial step, for example, they'll tell the density is like inversely proportional to the radius. If you mess up the initial step, you're gone. And it's like you're if you get the initial step right, the next part will be easy. Next part is chill. And then probability, I feel it's like a very chill a very chill unit, because you don't have to do like no lengthy calculations and all, or no lengthy derivations, no lengthy equations for that matter. It's just like you have to use logic, and you can crack the question in like 3-4 lines. Laplace transform, oh yeah, this is what, from here is what people start walking away. So don't worry. So Laplace transform, it's just remember a bunch of formulas, and mainly like division by s, multiplication by s, or whatever that is. Even I didn't revise. It's like multiplication by t, division by t, not s. I think that comes in inverse Laplace. So yeah, multiplication by t, division by t, all that stuff. If you remember the formulas, I think most of your work is done. And I think more than this, you have to focus on inverse Laplace. At least in ISAs, you get a lot of MCQs. But yeah, for ESA, I think now our goal is ESA right now. So for that, honestly, I haven't seen, but it's gonna be like those lengthy numericals or stuff like that. So practice. I know you hate hearing this word from all the math lectures, but it's just practice. Fourier series, I would say that's such a chill topic, because all you have to do is just remember formulas for a naught, a, and you'll be good. And then you have to just know if it's odd or even, and find if it's half range, cosine or sine. And then you have periodic and complex. Complex is just you have a formula, and just use it. Periodic also, same thing. Yeah, so this is sorted. Fourier transform is where it starts to kind of get complicated because of all those properties. Don't worry, we'll try our best to do a good job covering those. But yeah, generally I think it's like, I feel it's a bit questions wise, I would say it's uh, like it's kind of condensed into a few questions, where each of them is like, it has its own story to tell. It's like it's gonna be like mostly either lengthy, or like they're gonna trap you in some step, or it's gonna be easy. Some of them are gonna be easy. So yeah, in this, the properties, like the proving stuff that might make you go mad in the exam. So yeah, we have to just practice that, and I think we'll be good. So don't worry, I think you can um, having a look at this, you'll just find out what are the weakness of each of these, what's your weakness when you read these, and just doing practicing based on that, I think that should be sufficient. So yeah, let's move on to the next questions. Hey guys, yeah, welcome back again. So let's continue from the 23rd question. So that is b x square plus y square. Oh yeah, before going to the 23rd question, let me just explain a very important thing, which is how to identify the 3D shape. Like in most of the cases, say you have, and say you have this one, you have two different equations. So here you can tell that the left hand side degree is gonna be 1, and here it is gonna be degree is 2. Here degree is 2, basically the highest power. You know what, you can to get the logic of how the plotting goes, in this one just put x as 0, you get 9 minus y square. And what exactly is this? This is the parabola. And now you put y is 0, this is another parabola. So that's basically like this, and there's going to be another parabola. And if you keep on changing the value of x and y, you can think that you have a parabola, and you just like rotate it, like keep rotating it, you're gonna get a shape of like a 3D parabola, or like that's called a paraboloid. And here when you put say x as 0, you have z square equal to y square. That's basically z as mod y. And in this case, the graph of mod y is like this, or yeah, like this for that matter. And when you put y as 0, you get mod x. So you have this figure, and if you just again rotate this, you're gonna get a cone shape. Just for you to logically think about it and remember. So here it's gonna be like a cup shape, something like this, and here it's gonna be cone shape. Trust me, this one is like mostly sufficient to plot all the curves, at least most of the curves for that matter. Or maybe they just ask questions based on these curves. So yeah, 23rd one. X square plus y square dx dy dz. Yeah, paraboloid, I hope you understood what exactly it is. Let's just anyways have a look at yeah. And one more thing here, okay, wait, let me just write the equation of the paraboloid they've given is z equal to 9 minus x square minus y square, and they've told, and the plane z equal to 0, right? So the paraboloid here, logically if you think, when you put x as 0, y as 0, you have some value of z, that is going to be 9. But how do you know if that is like passing through the origin, or like what exactly is the case? And my bad, not just passing through the origin, whether it's like shaped in this way or is it like this. So let's just take this one for now. Z equals 9 minus x square minus y square. Yeah, so this is how it is. Like, this is, you can see it's like a parabola rotated, uh, 360 degrees. You're gonna get this figure, and you can see that it intersects at 9. Maybe it's difficult to see here, but uh, you have it intersecting at 9. This part is just 9, and you have 9 minus x square minus y square. You can see that y and x and y both are in negative. They are negative, so that's why the parabola is not going to be like this. Rather, it's going to be like this. So that's an important thing to keep in mind. And they've also told the plane z equals 0. Yeah, that's your z equal to 0. And the same thing here, what we do is just look at the shadow. So from the top, you see, what do you see? You just see a circle. Isn't that very simple to visualize? Like, basically how to solve. It's like a simple way to get to know how to solve. So from the top, when we have a look at it, yeah, again, how do you take the shadow? You just either, like, in crude term, you can tell that just put this value in this and you get the equation, that is your shadow. But in actual logical sense, it's when you intersect the two curves formed by having variables z. So in this case, when you take the intersection, it's going to be x square plus y square equal to 9. That is, you put z as 0, and ಇದು ಮೇಲಿಂದ ನೋಡಿದಾಗ it's just going to be a circle. And yeah, your job is to find out the part, like this circular part, like that area. Oops. Yeah, so in this, what do we know about this? And yeah, they told us to use cylindrical coordinates, right? For cylindrical, yeah, obviously we'll have to look at we need r, theta and z. So you know what is r? R goes from what? 0 to 3, because 3 square is 9. So r goes from 0 to 3. What about theta? It's pretty simple, 2 pi. 0 to 2 pi. And now we'll have to talk about what z goes from. And in most of the cases, it's the same fundamental concept. It is what's our main goal of this question? That is to find the volume which is bounded by that region. So from which curve to which curve are you going? Over here, you're going from z equal to 0 to you're going to z equal to 9 minus x square minus y square. Basically, you can consider that as one of the strip. But the thing is, if you're not handling it one second. Yeah, so the thing right now is, when you solve it in terms of Cartesian z, that's going to give you the answer based on like x square or y square, whereas we have parameters in the form of r and theta. So we must convert this to r and theta form only. So what were our limits for z? 0 to 9 minus x square minus y square. In polar also, it's just going to be 0. And what about 9 minus x square minus y square? That is just going to be 9 minus x square plus y square. And we know in cylindrical, this is just r square. So 9 minus r square. So we have this limit, and we have limits for this also. And now our job is very simple. The integral, whatever they asked, is just going to be z goes from 0 to 9 minus r square, and r goes from 0 to 3. Theta goes from 0 to 2 pi. And oh yeah, you'll have to make the substitution also. That's still simple. X square plus y square is what? As I told, it's r square. And then we have dx dy dz. Write the Jacobian for cylindrical. Also the Jacobian is r. So r dr d theta dz. Obviously you just change this based on what order this is in. So in that case it's just gonna be r cube and dz dr d theta, and just solve this. Solve and get 243 pi by 2. Okay, let's go to alright, now let's go to the 24th question. And I love this question because it explains a very it's like you should not just rely on formula. If you just rely on formula, you're gone. Don't rely on formula, just remember the concept and then use formula. Because if you see the class notes, it's mostly gonna be a very long calculation or very long step to actually get to the limits. Whereas I'll tell you the method. Using this, it's like pretty simple to get to the limits. So first of all, wait, let me just write down the question. 0 to 1, 0 to square root 1 minus x square, 0 to square root x square plus y square, 1 by x plus x square dz dy dx. Okay, here they've given dx dy dz. Okay, don't freak out because this is z, this is y, this is x. If they've given the wrong order, you write it properly, don't panic. And yeah, so now you'll have to worry about the limits and then the solution. For now, the limits, I'll tell you a very simple way. It's a very fun way. Okay, what are the things in the picture? One is this part. Obviously these are just constants, so you can imaginarily, you can easily draw that in your mind also. But this is this one and this one. These two are the main barricades for this question. And so if you take this is y, this is z, this is x. So if you do y equal to square root 1 minus x square, and if you do z equal to square root x square plus y square, and also consider z equal to 1, I'll tell you. So if you consider this one for now, using the trick I told, this trick, you can see that the degree is just z square equal to x square plus y square. So it is gonna be a cone shape like this, right? So let's just draw that. And you have a cone and you have z equal to 1. So let us just draw z equal to 1. This is the plane, z equal to 1, right? And this is z, and you have x and y as well. So now they're they've also given you this. And what is this? This is basically just a circle. Oh wait, my bad, it's not a circle. It is y goes from 0 to this quantity. So it has to be a semicircle, because this part is square root 1 minus x square, and if you had this part, the red part would be minus of 1 minus x square. So it's just y0 and ಇಟ್ಕೊಂಡು square root 1 minus x square ವರೆಗೂ ಹೋಗ್ತಿದೆ. So it is this part, and that's not where it stops. You also have x equal to 0 to 1. So that means x goes from 0 to 1. So it is just this portion. This portion is not there. This portion is there. So if you see it from the top, if you see it as a shadow, this part, the shaded part, is just one octant. It's just one and only one octant, the positive one. You might ask, if you're confused, it's totally normal to get confused. Just this is x this is y. So in physics we show a notation to tell that it is coming towards us or pointing towards us. So just assume this red color thing is z direction, and so this part is just your first octant, right? And so for the first octant, let me just draw a much clearer figure. This is your z, this is your y, this is your x. So we have our little cone here, and let's take the shadow so that it becomes simple to understand. You get a circle, as I told. And what is the equation of this top part? It's just x square plus y square equal to 1. Obviously the cone will have an equation, but for now, yeah, just if you take this, we have to go, yeah, again, why I really like this question is because it teaches you about the strip concept, and it teaches you about what do you say, the shadow, obviously, and apart from that, yeah, I think I'll tell you how it goes here. Oh yeah, and also the angle phi. So in this, they've considered z equal to square root x square minus x square plus y square to 1. So that basically means x square plus y square root x square plus y square is just the cone, and it goes till 1, or I mean, sorry, not this, yeah, this plane is z equal to 1. So it goes from, so z goes from the cone to the z equal to 1 plane. So that's why that clears stuff. And you might be wondering, yeah, exactly, why are we not taking this area, and why is the area only this part? That is because of this line, like this point. So yeah, now we saw the shadow. In the shadow here, what information do we get? We get to know about theta. So theta goes from what? 0 all the way up till pi by 2. So you got theta 0 in the pi by 2 or and then what else do we need? We need r and spherical, right? My bad. You need rho and you need phi. So for phi, this is where things shine, okay? This part, like this figure, the effective figure we are finding out is just this much. So say you have like a very solid ice cream cone, and say you cut that in half, and you cut it like this also. I think the one thing you'll be left with, that should be the figure we are working on. And for that, we have theta already. We need to find phi. Phi, you remember that laser gun example I gave you? In that, how my arm moved. So if you consider this as my arm, and it rotates only till here. Yeah, for example, you take this. So yeah, my arm was here, and it rotated like till here, and that angle which it rotated by is just pi by 4. Basically, z axis in the, you rotate it till you get the figure. That is your phi. So in this case, why did I tell it's pi by 4? Because it is a normal cone is gonna have that equation, like mod, if it's like mod x mod y, the angle will be 45 degrees. So we got phi as 0 to pi by 4. Now what about r? Again, I like this question because of the concept of r also. R henge illinda hitkondu, it's gonna go till the function. So here r goes till here, r goes till here. So that makes it like, obviously it starts from 0, that we know, and then r goes to an arbitrary point, or it goes to a set of arbitrary points, and that is nothing but your you have. Yeah, so to find the limits for rho, we know this lower limit is going to be 0. What about the upper limit? So what we've been learning so far is upper limit is what is going to be defined by an equation, or basically an equation which is going to be satisfied for multiple points. So in this case, rho varies from 0 and it goes all the way till here. And what is the equation for this? It's just z equal to 1. So you have z equal to 1. And what is z in our substitution? We have x as rho cos theta sin phi, y is rho sin theta sin phi, and z is this rho cos theta. So we have our rho cos theta equal to 1, and our rho is basically secant theta. So the upper limit is going to be secant theta. So these are our limits. So it's basically from which function to which function you're going, and what is, obviously we can't write like z goes from the cone to that next function, because now we are converting it into spherical coordinates. So if we are converting it into spherical coordinates, we have to write all our we have to write everything in that language. So we have our limits. Now let's write the integral. So this is just going to be theta. Wait, what is the inside? Oh yeah, and x square plus y square is just plus z square is just going to be like r square. And here you can see it's like so you have your rho which goes from 0 to secant theta, and then you have your theta which goes oh wait, I think I made a small mistake, my bad. The substitution here is gonna give you z equal to rho cos phi, my bad. So upon doing this, you'll get rho cos phi, and then you're gonna get secant phi, and once you put this, you're gonna have secant phi here, and your phi varies from 0 to pi by 4. Your theta goes from 0 to pi by 2, which we just discussed. And what is our inner integral going to be like? We just have dz dy dx, and once you apply the Jacobian, you're going to get rho square sin phi d rho d phi d theta, and in the root this is just r square, so it's root r square, sorry, rho square, my bad. And just cancel this, don't worry about the mod, like technically this is mod rho, but it's fine. So you're gonna get what, rho sin phi d rho d phi d theta. Put the limits, and once you solve it, you're gonna get the integral as, see, it's actually not, integration here is not that hard. Okay, this is 0 to secant theta, this is 0 to pi by 4, and theta goes from 0 to pi by 2. You just get the integral as pi by 4 root 2 minus 1, and that should be your answer over here. Yeah guys, so let's go to the 25th one. Zero one minus 1, 0 to 1, 0 to 1 minus x square, 0 to 1 minus x square minus y square, dz dy dz 1 minus x square minus y square minus z square under root two spherical. Okay, two spherical. Yeah, so in this also the starting part, this part remains the same, the logic remains the same. So you have z, y and x. So this is y 1 minus square root 1 minus x square, and 0 to 1 is just this much, and this signifies first octant. But first octant of what is the question? We have the function of z, so z goes from 0, fine, we'll keep that in mind. And then we have z, the upper limit is 1 minus x square minus y square. Yeah, obviously if this was in Cartesian you can directly solve it, but it's gonna take so much of time, so that's why we're converting it to spherical. And z square equal to 1 minus x square minus y square, so we just have x square plus y square plus z square equal to 1. This is basically a sphere of radius 1. So let's just convert everything to spherical. So x becomes rho cos theta sin phi, y is rho sin theta sin phi, and z is just rho cos phi. Yeah, so we have a sphere of radius 1. That means we have a sphere here, and we have to just take the first octant of it. So the first octant only would be a small part, the red part. This is a sphere, one octant of the sphere. So if we put, yeah, so what are the limits again? So yeah, we have the 2D boss angle theta, which goes from 0 to pi by 2, because it is 0 to pi by 2. And then you have a sphere, right? So just assume again, I'll take the example of an orange. Say you have an orange here, and say you put a string, or say you put a straw inside that, and you're asked to find out the basically assume that only one octant is there, one piece of it is there. Okay, and this is the first octant. Now from the string to this outer part of the orange, you have to measure the angle here. So this theta is just pi by 4. The same logic we used for the previous question. So your phi is gonna be, oh wait, yeah, my bad, it's not pi by 4, it's pi by 2, because it's not just till here, you're going till this part. So theta will be pi by 2, phi will be pi by 2, 0 to pi by 2. What about the radius r? As it's just this one part of the octant, I'll draw this figure, it's gonna be even more clear. The octant is basically gonna look like this. Yeah, so your theta goes from 0 to pi by 2, and your phi, which is from here, it's gonna go like this, and it's gonna cover this entire outer portion, like the peel of that orange. It's gonna cover from the string to the peel of the orange, and this angle which it is gonna cover is phi, which is 0 to pi by 2 again. And the radius is what? You have radius rho is starting from 0, and when it goes till the peel, it's gonna be 1, because we just found out the radius is 1. So we have our row 0 to 1, and just make the substitutions. You'll get the integral. Let me just copy this. Yeah. So from here we just have again 3 parameters, which are going to be rho is 0 to 1, and then you have phi from 0 to pi by 2, theta from 0 to pi by 2, and if you put the Jacobian, it's going to be rho square sine phi d rho d phi d theta, and this is just going to be 1 minus x square plus y square plus z square is just r square, so 1 minus rho square, not r square, rho square. So you solve this and you'll get pi square by 8. Okay, let's go to the 26th one. Let's go, last 2 pages left. Evaluate x, y, z, x square plus y square plus z square. Volume V, x, y, z, x square plus y square plus z square, 1 by 2. dx dy dz, dx dy dz through the positive octant. See that? They have given it, so it's a bit simple already. Positive octant of sphere. Yeah, the sphere is just x square plus y square plus z square equal to b square, which they have given. And provided n plus 5 is greater than 0, what should we find? Evaluate that through positive octant. Yeah, so look at this. You can orally tell the limits. Positive octant, so that means theta goes from 0 to pi by 2, phi goes from 0 to pi by 2, and your rho goes from 0 to b square, 0 to b, because the sphere equation they've given is x square plus y square plus z square equal to b square, so your radius is gonna be b. Alright, and yeah, that's it. Like, the limits we found out, just make the substitutions, and it's gonna be what? 0 to b, 0 to pi by 2, 0 to pi by 2, and xyz, this part is gonna be yeah, including the Jacobian, it's gonna be rho square sine phi into x is rho rho cos theta sine phi, and cos y is gonna be rho sine theta sine phi, and then z is gonna be rho cos phi. Yeah, so our z is gonna be rho cos phi, and x square plus y square plus z square n by 2 is gonna be rho square n by 2, and this was d rho d phi d theta. So the integral is gonna become what is it gonna become? You have sine. Yeah, you're gonna be getting 0 to b rho n plus 5 this 2 gets cancelled, and you just add the powers of these row. D row, and integral 0 to pi by 2 sine cube of phi cos phi d phi, and obviously 0 to pi by 2 sine theta cos theta d theta. So once you evaluate these integrals, I'm gonna skip that, I'm sorry. You're gonna be getting the integral as b power n plus 6 by n plus 6, 1 by 4, 1 by 2. This is gonna be b power n plus 6 by 8 into n plus 6, and I think that should be the answer. Yeah. So moving to the 27th one. Find the area bounded by the parabola y square equal to 4x and its lattice rectum. So we have y square equal to 4ax and its lattice rectum. So lattice rectum is basically the line which passes through the focus. So y square equal to 4ax, we know that is like this, and the focus is at A. So the lattice rectum is gonna pass through x equal to A, and the value here will be 2A, the value here will be minus 2A. That's why they tell the length of the lattice rectum is just 4A, 2A plus 2A. So yeah, we are required to find out the area between this. So let's draw this first, and then its lattice rectum. So this is what, A comma 0. This is y square equal to 4ax. So our job is to find out this area. So let's just take a horizontal strip, and yeah, this is, by the way, as I told, minus 2A, this is plus 2A, x, y origin, and this is basically x equal to A. So we have the limits as x will go from this function. Again, as I told, strip, the concept of strip is just one function to another. So in this, the value of x is just y square by 4a, and here the value of x is just a. So you have x going from y square by 4a to a, and in that interval, what about y? So from here till here, or yeah, you say you're moving the strips like this, you get y goes from minus 2a to plus 2a, minus 2a to plus 2a. So the integral will just be minus 2a. Again, I'm telling you, the outside limit must be a constant. Y square by 4a to a. And here, if you get the answer as negative, just make that positive, because area or volume can't be negative. So once you integrate this, you're gonna get minus 2a to 2a, a minus y square by 4a dy is just a into 2a plus 2a minus a into y cube by 4 into 3 is 12a, and put minus 2a plus 2a here, and just move this a bit. Yeah, 4a square minus 8a cube plus 8a cube by 12a. This is 4a square minus 16, 4a square by 3. This is 12 minus 4, 8, 8a square by 3. Is it? It is, yeah, it is 8a square by 3. Fine, let's go to the 28th. Find the area bounded by the curves xy equal to 2, x square equal to 4y, y equal to 4. The fundamental step, just graph all them. Xy equal to 2 is just a hyperbola, and x square equal to 4y is a parabola, y equal to 4 is a line. So x square equal to 4y is gonna be somewhat like this, and your hyperbola is gonna be like this, and the straight line is this, y equal to 4. And the point these intersect at is gonna be 2, 2. My bad, this is gonna be 1, so 2, 1. So these points are gonna be just 2, 1, and our job right now is to find out the area, and in this case it is this region. So let's take a horizontal strip again. Horizontal strip, and what are the limits of the strip? It goes from blue function to white function. So what is the blue? And yeah, obviously we have to vary x. So x on the blue function is just 2 by y, and it goes till the white function, which is the parabola. We have 4y, so it's just root 4y. What about the value of y? And yeah, this is, by the way, y equal to 4 line. So from here till here you have to find out the y change. So y goes from 1 to 4. Yeah, it does go from 1 to 4. So the limits are going to be 1 to 4, 2 by y, 2 root y, and the function is just dx dy. This is gonna be 1, 4, 2 root y minus 2 by y dy, and this is gonna be 2 y half is y 3 by 2 and 3 by 2, so 2 into that, and minus 2 plus 2 by 2 y square. Just integrate it, you're gonna get that. And now put the limits. Oh wait, no, I differentiated it. 2 by y, this is just gonna be 2 ln y, and you have to put the limits 1 and 4. This is gonna be 4 into 2 power 3 is 8 by 3. Basically 4 power 3 by 2 is 2 power 3 plus 2 ln 4 minus 4 by 3 plus 2 ln 1. ln 1 is gonna be 0. So what do we have? 1 second. So we have oops 32 by 3 plus ln 4 is just 4 ln 2 and minus 4 by 3. This is 28 by 3 plus 4 ln 2. I don't know if this is right. Minus 16. Oh, I think it's almost right. So yeah, it's just 4 ln 2 is 28 by 3. I don't know why did they get a minus sign. Oh yeah, I integrated it and by mistake I put it as plus. This is going to be minus 2 itself, and here it's going to be minus. Here it would have been minus itself, right? Yep. This is minus 4 ln 2 is just ln 2 my bad, ln 2 part 4, which is just 16. So minus ln 16. So that's our answer. Okay, now let's go to the 28th one and the 29th one, and before that let me just tell you this important part. So circles, the roses petal, the petal roses thing we discussed that time. Just ignore this and try to remember these formulas. But yeah, for now let's make use of circles. Like, just remember that a cos theta will give you a circle like this, and sine theta is going to give it to you in the upward direction. Just remember when it's going to be to the right, when it's going to be to the left. Yeah, obviously if you remember for a cos theta, and when if the curve is like this, for a is positive, if you negate that, the curve will be here. That is like simple logic. So in the luminosity and all this stuff, like, just try to remember. Maybe this is not required, I don't think so. This is there, this one I'm not sure. So yeah, for the 29th one, we have find the area inside the circle, r equal to 2a cos theta and r equal to a. 2a cos theta and r equal to a. Inside and outside, fine. In, out. So what about 2a cos theta? What is the direction? It's going to be like this, 2a cos theta. So we'll be having, if it's 2a cos theta, when we plot this, it's going to be to the right. Something like this. And you have r equal to a, which is just a normal circle like this. And note that this is your a comma 0. R equal to a, r equal to 2a cos theta. And they've told us to find inside the circle and outside the circle. So that is nothing but this part. And you can't use Cartesian here. I mean, you can use, but it's not advisable to use Cartesian because it's gonna take a long time. So your r is gonna vary, like you have to take polar. Okay, So let's take the, consider the limits for r. So r will vary from this to this. So basically a to this circle, the radius of this is determined by this equation. So that's why r goes from r equal to a, that is until the blue circle. It's going to start from the blue circle and it's going to go till that boundary of the white circle, that is 2a cos theta. And you might be wondering, what about the angle of, for the values of theta? So you can see that the integration, like the area, the vector is going to go only till here, like only in this area. So we need to find theta here, that's it. Like start from this theta, go all the way and stop at this theta. So for that, just draw like a line here and find this intersection, and or you just find out the value of the value is just going to be a by 2, and put that in this equation to get the value of theta. So you're going to get the value as what? A by 2 equal to 2 by a cos theta, I guess. Wait, no. Yeah, my bad. So here the radius, consider the blue, consider the white circle. Okay, yeah, so there's a simple way to find out what this angle theta is. So you have r equal to a and you have r equal to 2a cos theta. So if you just divide them, you're going to have 1 by 2, 1 by cos theta. Basically you're going to have cos theta is 1 by 2, theta is just pi by 3. So this is pi by 3, this is minus pi by 3. So your theta goes from minus pi by 3 to pi by 3. Now you put that in the integral. R goes from a to 2a cos theta. Theta goes from minus pi by 3 to pi by 3. Put the Jacobian, which is r, and then dr d theta. Integrate this and you should be getting something like a square by 2 into 2 pi by 3 plus root 3. As I told, just evaluate the first integral and then go to your calculator and you'll get the answer. Maybe here you won't get, because a is you can't put like a variable in a and variable in calculator and expect it to do the integral. But yeah, in other cases you can use the calculator. So this is also done. So let's go to the 30th one. Find the area bounded by the curves x square equal to y cube and x equal to y. X square equal to y cube and x equal to y. The same grind. You have x square equal to y cube. Let's just plot it. Take values for x and y. So when x equal to 1, for x square equal to y cube, when x equal to 1, y is 1. When x is minus 1, y is plus 1. When x is 2, y is just cube root of 4. So if we put these points, At 1 you're gonna have 1, minus 1 you're gonna have 1. At 2 you're gonna have around cube root of 4. So I think somewhere like this. So it's gonna be like this. You take more points to get a much smoother graph, but for now this thing works. And then you take x equal to y equal to x. This is x square equal to y cube, and you have to find the area bounded by this. Let us take vertical strip. You can take horizontal also, but let's just consider vertical strip now. The limits you're gonna have are gonna be first y value of the first graph is just y is x, and it goes till the white function, and there the value of y is x square 1 by 3. And then you have x which goes from what is this, by the way? You'll have find the intersection. So x square equal to x cube, so x square into x minus 1 equal to 0. So it's just x equal to 1 at this point. We'll have x going from 0 to 1, and yeah, so if you integrate this, you're gonna be getting y goes from x to x 2 power 2 by 3, and then y goes from x goes from 0 to 1, and yeah, it's just dy dx. And once you solve this, say you get the answer as negative, just put it as positive. But yeah, in this case we are going to get positive answer only. So yeah, the answer will be 10. It's a very simple calculation, and yeah, that's going to be 1 by 10. So yeah, 30 done. We have 12 more to go. Let's finish it. Oh my god. Yeah, so the 31st question, it says you have a cylinder, you have these two planes, and you have to find the volume using double integration. So if you just put them on Desmos, one for the cylinder, we have y plus z equal to 1, we have z equal to 0. So we have this figure, and our job is to find this volume. This volume, and yeah, obviously in 3D itself, like even this portion also. So if you see the diagram, it's gonna look like this. It's to plot it, it's not hard. It's just one cylinder. It's just a cylinder, and you have like a plane. Right, and your job is just to just ignore the symmetry. Okay, it's symmetrical in the actual image, but yeah, here this plane will cut like a circle from the cylinder, and there will obviously be another circle here which the z equal to 0 plane will cut. So our job is to find out this yellow color region, and they've told double integration, so you won't have the variation of z. You have to take z as a function. So here they've given the equation y plus z equal to 1, so z will just be 1 minus y. And yeah, let's take the shadow, and Shadow is basically you viewing it from the top, and that region is just gonna look like a circle. So it's like something like this, right? It's like this, but when you look at it from here, it's gonna look like a circle. So you have a circle, and what's the equation of this? It's just x square plus y square equal to 1. And is it a complete circle? Yes. So we have our limits, and this can be done in Cartesian also, but let's just consider it in polar because it's going to be simpler. So we have radius which goes from, this is 0 and this is 1. So 0 to 1, your theta goes from 0 to 2 pi, and yeah, that should be it. So your integral will just become over the region of x comma y dx dy. We know this. If it was if they had asked it in triple integral, you would have considered the region here, and you would have done dx dy dz, but they've asked like only double integral. What is this? Yeah, triple. But as they've asked only double integral, what we can just do is put in the limits. So r goes from 0 to 1, theta goes from 0 to 2 pi, and you have, what's the function here? It's just 1 minus y, and y in terms of polar is 1 minus r sine theta, and the Jacobian is r, and then r dr d theta. So the volume is just gonna be 0 to 2 pi r square by 2, 0 to 1, and you have minus r cubed by 3 sine theta. Yeah, this is also 0 to 1. Now put the limits. Oh, sorry, not the limit. Yeah, integration. So now your v, this one will become 1 by 2 minus 1 by 3 sine theta, and this is from 0 to 2 pi again d theta. So v is going to be theta by 2 plus 1 by 3 cos theta, 0 to 2 pi. So cos 2 pi and cos 0, it's gonna be the same, so it's gonna cancel out. So theta by 2 is just 2 pi by 2 minus 0 plus 1 by 3 into 1 minus 1 by 3 into 1. So yeah, your v is just gonna be 5. Yep. Now the 32nd one. Find the volume of the solid that is below the plane 2x plus 3. Z equal to 2x plus 3, and above the plane and above the plane xy. I think x hyphen y just means that it's the xy plane, and is bounded by y square equal to x equal to 0, and x equal to 2. Yep, again we have to use double integration. I think this is fairly simple because again you have to consider your f of x comma y as z, which is 2x plus 3, and you just plot y square equal to x. That is going to give you this, and you have x equal to 0 and x equal to 2, and you are required to find the area, obviously, so it's this area. So our x goes from wait, we have to take let's take strips in this direction. So our x will go from this function, the white color graph, which is y square, to x equal to 2. And what is the value over here? Put x equal to 2 in the parabola, you're gonna get root 2. Here it's minus root 2, you're gonna get plus root 2. So x goes from y square to 2, y goes from minus root 2 to root 2. So our integration will just be x equal to y square to 2 and y equal to minus root 2 to root 2. And yeah, what's the function? 2x plus 3 dx dy. Solve this and you're gonna get some long answer, but it's gonna be correct, I'm sure. Yeah, I think you'll get the answer. I'll just write it down. 72 root 2 by 5. 72 root 2 by 5. Okay, now let's go to another one. By the way, only 10 questions left. (33) Calculate the volume of the solid bound by the paraboloid z equal to 2 minus x square minus y square, and the cone z equal to square root x square plus y square. You have to find the volume. Again, the same thing. If they hadn't told you that this is a paraboloid and this is a cone, you should be smart enough to identify the curve. This one requires a bit of plotting, because to get the limits, the z limits, it's just one function to another function you're going, and the value of z. And here it's going to be very convenient if we take I think we can take cylindrical, because x square plus y square is going to be r square. So hence we'll just take cylindrical. And for cylindrical we need a top view of it, so we'll have to plot it. So what is the paraboloid telling you? Like, put x comma y as 0 in the paraboloid, you're gonna get z equal to 2. That means, and yeah, x and y both are like negative. So if this is z and if this is 2, paraboloid is not going to be like this. It is going to be like this. So, and yeah, we also have the cone, and this is passing, it's a standard curve passing through the origin. So if I have to draw this, we have our cone and then also our paraboloid somewhere like this. You can close it. It doesn't matter when you're viewing it from the top. Yeah, and did they tell something else? Okay, no. So our job right now is first to view it from the top. View from top, or take shadow. And when you're looking at it from the top, what you're gonna see essentially is a circle, right? And your job is to find out the radius of that circle. See, I told you can close it here. If you let that open, it's just gonna extend till infinity. And but you need the area or volume only within, it's governed by the radius of this cone. So that's why I just put it here. You can just leave it extending. It just shows that this is like a 3D figure. So if you view it from the top, you're gonna see just a circle, and the radius of it is basically, it's a circle having the equation x square plus y square equal to 1. So we have our r and theta values, which I know you're definitely comfortable with right now. So r goes from 0 to 1 and theta goes from 0 to 2 pi, and the region we are interested to find out is obviously this, right? And for this we'll have to again take the strip concept again. We'll have to go from one function to another function, and for that let us take it's going from the cone to the paraboloid. So it's like cone to paraboloid. Again, if you interchange it, answer will come negative, and you can just take the absolute value. So what are your z values gonna be? So z is just gonna be x square plus y square to 2 minus x square minus y square. This is what? The cone to the paraboloid. Paraboloid. So in terms of polar, z will just be r square, because x square plus y square equal to r square, and here it's gonna be z equal to 2 minus r square. So that's it. We have our limits now. It's just the integral will just be z will go from r to 2 minus r square. Your what do you say? Yeah, your radius will go from 0 to 1. Your theta will go from 0 to 2 pi, and the integral will be, obviously in taking the Jacobian, we'll get r dz dr d theta. Remember the order. So yeah, I think you solve this and you should get the answer as 5 pi by 6. There you are. So now going to the 34th question. Find the volume of the smaller region cut by the solid sphere and z equal to 1 using spherical coordinates. Well, I've plotted this. I'll show it to you. Yeah, they've asked us to find the volume of the smaller region cut by the solid sphere. So we have a sphere having the equation x square plus y square plus z square equal to 2, and we have our plane, which is z equal to 1, and we have to find the volume of smaller region. Volume of smaller region. Obviously, like on paper you can plot it. It's just going to be a sphere of radius 2, and z equal to 1 is just a plane. So you know that it's going to be like this, and you're going to have something like this, and they've told us to find the volume of the smaller portion, which is just this much. But I'll show it on Desmos, it's much clearer. So you have this, and our job is to find out the volume of this portion. Obviously, if they told the larger portion, it would have been this. Common sense, but yeah, for now it's just the smaller portion. And here it's just so better to use spherical coordinates because it's already a sphere which they've given. So yeah, first of all, what about the 2D boss angle? When you view it from the top, it just looks like a circle. So it is gonna be a full circle. So your theta will go from 0 to 2 pi. Let's go. One thing is already sorted. And now coming to the, I guess, lateral angle or something, phi. it's like you have that vector here, and you're moving, and you're coming till here, and our job is to find this theta. uh, for this, what we can do is we have so we have our sphere over here, and we have our plane, and the point on the plane here is gonna be 1. This is z, and the radius, like basically where it's intersecting. So this point, the value of the blue color plane, you see that has the value z equal to 1, and you have the radius, like basically the radius of it is √2, right? So it's like, if you observe the green line, this part is 1 and this part is gonna be your √2. It feels like kind of wonky, but if you go to that plane, it's going to be a proper like you can use Pythagoras and find out. So yeah, let me just so what did we just tell? We have this as 1, we have this as √2, and our job is to find lateral angle 5. So if we just, and note that this is the right angle, by the way. So you will have cos phi is just base by hypotenuse, so our phi is just gonna be pi by 4. That's it. And obviously phi will go from 0 degrees, or say let's just take 0 radians, to pi by 4 radians. So we have our 2D boss angle done, we have our phi also done, which is phi is just 0 to pi by 4. Now our only job is to find out the radius, and for finding out the radius, it is just us going from the plane to the sphere. So the radius is just like the rho vector, or the basically the line. It goes from the plane, like it starts from the plane and it goes up to the sphere. So it's very simple to calculate. So the equation, basically z is going from z equal to 1 to z equal to the equation of this. So 2 minus x square minus y square, I guess. Yeah, square root of this. But we have to convert it in terms of the radius vector. So we have z is what? It's just gonna be rho cos theta. Correct. Rho cos phi. Rho cos phi equal to 1 to 2 minus x square minus y square is just root of 2 minus rho square, right? Oh no, my bad, wait. I think I complicated it over here. Okay, like z definitely goes still here, but rho just goes from this point to √2, because the radius over there is just √2. So yeah, and what is this? It's just rho equal to secant phi to √2. That's it. We have all our limits now. Our theta goes from 0 to 2 pi. Our phi goes from 0 to pi by 4, and our rho goes from secant phi to √2. So in integral, it's just gonna be v equal to 0 to 2 pi, 0 to pi by 4, secant phi to √2, and using the Jacobian, it's gonna be rho square sine phi, which is our Jacobian, and then d rho d phi d theta. You solve this and you should be getting 4 root 2 minus 5 by 3 by. Kindly solve it, please. Yeah. And find the total mass of the region in the. So yeah, now moving to the next question onwards, we'll need these concepts. So first of all, what's an average value of a function? You understand what it literally means, right? Like average value of a function. But to give you the actual logical sense of it, think of it as a weighted average, because this is just say one term and you're multiplying that with the value, so it's going to give you a weighted average. Honestly, just try to remember the formulas that should do the job for that. And now moving to what's called as total mass, and this is helpful in case of when there's density. Let me give you a simple explanation on this. So if you have single integral, that is going to give you the area, and if you have double integral, that's going to give you the volume. And you do have triple integral giving you volume, but that is only given that you have dx, dy, dz. This is going to give you the volume, I agree. But what if we have like triple integral f of x comma y comma z dx, dy, dz? This would have given you volume, but this thing is taking you to the fourth dimension, and I don't think we know a term in fourth dimension which is going to like give you like basically a quantitative term we can define at this stage. So that's why just recall the formula of density, mass and volume. Density is just mass by volume, so you can write mass as density into volume. So if you have volume and if you have density along with it, then there's no harm in integrating it thrice, because that would still keep you in the it's not gonna take you to fourth dimension and above. You can see here it's mass, this is the density, surface density. So if it's 2D, you take mass per area, whereas if it is 3D, you take mass per volume. So density, area, density, volume, and you get the mass using this formula. Then moment of inertia. Yeah, I don't think you have to go in deep to the physics of this. Just remember the formula. It's just if it's x, it's just y square, because it's perpendicular distance from that axis. And I'm sure all of you might have learned it in mechanics. So yeah, you have ix, you have iy, and I naught is just ix plus iy. I think these are just self-explanatory. You can just memorize them. Even the center of gravity. Yeah, I guess all you gotta do is just remember for now. That should do the trick. So let's go to the 35th question. It's like total mass of the region in the cube with density at any point given by xyz. So we just know the formula of total mass, and it's 3D. So it's just f of x, y, z and dx, dy, dz obviously. And the density they've given it to be x, y, z. And they've given what? 0 to x. Sorry, yeah, 0 to 1, 0 to 1, 0 to 1. And we have to find total mass. Yeah, using that formula, we can just write it as x, y, z, dx, dy, dz, and the limits they've only given it like it's straightforward. X goes from 0 to 1, so does y, and so does z. Now you can obviously split this, write it as 1 x dx, 0 to 1, 0 to 1 y dy, 0 to 1 z dz. This is just 1 by 2, 1 by 2, 1 by 2. So the total mass is 1 by 8. So 36th one, find the mass of a sphere of radius b if the density varies inversely as the square of the distance from the center. Okay. Radius is b. Density is varies inversely as the square of distance from the center. Yeah, and yeah, so as it is like the radius is b, and from the center to that point is basically your the radius. So all you can you can just write it as wait, first of all, the radius can be written as we can write the equation of the sphere as x square plus y square plus z square. From this we know that the radius is b square, and yeah, you know that the distance would be square root of this, but they've mentioned that the mass of something, right? The mass of sphere is, if the density varies inversely as the square. So we have density which varies inversely as the square of the radius. So the square would just become like proportional to x square plus y square plus z square, because b square is this is b square gives you this. So remove the proportionality constant, bring in a constant k, b square, and b square you just call it as, I think b square is good. So now as it is spherical, let's use spherical coordinates only. Spherical coordinates, yep. And yeah, what was the total mass, I guess? Yeah, find the mass. So this is just going to be xyz dx dy dz over the volume. We will talk about the limits. The substitution, anyways, it's rho cos theta sin phi, y equal to rho sin phi, and z is just rho cos phi. So our total mass will be it's gonna be what, k by b square dx dy dz over the volume. We'll talk about that. So the volume in this case is like very simple to calculate. It's just a total sphere, right? So the limits are just going to be theta goes from 0 to 2 pi, then your phi goes from 0 to pi. In this the reason why it is 0 to pi, I'll explain it shortly, for completing a full sphere. And then you have r which goes from 0 to b, and put the Jacobian, and I think let's just call this as r. That's why I realize it now. Let's just call this as k by r square, so that will be simple to handle it later. So the Jacobian will be r square. You know what, let's just take it as rho, because we've been taking rho from the start. I don't want to confuse you guys. We have density also. Call the density as d. So this should be rho square sin phi by rho square. We have d rho d phi d theta. Cancel. I forgot k. So k just comes out 0 to 2 pi, 0 to pi, 0 to b, and what are we left with? Oh well, we can just distribute them inside. So with 2 pi we get d theta. With 0 to pi, for the phi variable we get sine phi, and we get d rho 0 to b. So we have this as k 2 pi minus cos phi from 0 to pi, and this is just r with the limit 0 to b. 2 pi k, and this is just going to be minus of minus 1 minus 0, sorry, minus 1 as well, and this is just going to be b. Sorry, this was rho. This minus will get cancelled with it, so you'll have 4 pi k into b. Yep. Going to the 37th one. Compute the moment of inertia of a right circular cylinder of altitude 2h, radius b. Okay. Altitude 2h, radius is b, and then relative to the diameter of its median section with density equal to k. So density is k. Yeah. So this thing, when I solved it in the first, it was a bit tricky. So, but now it's like kind of clear. Let me explain it. So for convenience, let's just take the cylinder in this way. And so the total altitude is 2h. So this is going to be h, and this is going to be h. 0. It's okay, fine. And we have to find the moment of inertia relative to the diameter of the median section. One thing you'll note that we can take the moment of inertia like this or like this, because it's symmetrical about both, but we can't take it along this. At least in this setup you can't take it in this direction. Otherwise, if you just tilt it, you can take it, because I've told median, relative to the diameter. So this is the diameter, so it should be like in terms with it, like either x or y. It can't be something like this. So for that reason, what we can write here, oh yeah, and obviously without any doubt this has to be solved using cylindrical coordinates. And for this, we know the substitutions. They are x r cos theta, y is r sin theta, and that is just z. So we know the density, which is k. But yeah, what is the main formula? So let's just take moment of inertia about x. Like we'll calculate ix. You can also do iy. So if you're doing ix, you write it as y square plus z square. Whereas if you would have written iy, you would have written x square plus z square. But for now, let's take this, and you have the density f of x, y, z, dx, dy, dz, triple integral obviously. So now what about the limits? For the givens, for the cylinder we took, it's just very simple. We have z which goes from minus h to plus h, and you have our radius which goes from 0 to b. They've mentioned the radius, and you have our theta which goes from 0 to 2 pi obviously. So the limits are just of a standard cylinder. So our ix is going to be, putting, making the substitutions in place of y square and z square. We get r square sine square theta plus z square, and the density is just k, which they've given. Put the Jacobian, which is r dr d theta dz, and put the limits. What are they? Minus h plus h, 0 and b, 0 and 2 pi. Again, if you're worried about the, you can obviously tell without thinking that the limits of r and theta are going to be this. But if you still found that difficult, just project or like take a shadow of it or look at it from the top. That should do the trick. And yeah, once you solve this, again I'm leaving it to you. You're gonna be getting the answer, don't worry. You're gonna have, oh wait, my bad, I think you're not gonna get that as the answer. Yeah, you're gonna get the answer as ix equal to 2 pi hk b power 4 by 4 plus b square h square by 3. Yeah, you'll get it in terms of this. So just please make that one correction. Two pi hk b power 4 by 4 plus b square h square by 3. Yeah, we're done with this as well. Just a few more formulas left. Few more. So we'll be doing the 38th one. And disclaimer, 38th one is very, very, very lengthy. Like I tried solving it, but I couldn't. And I saw the solution, and seeing the solution itself, it's so big. I don't know what to do. Centroid of lamina in the shape of a quadrant of the curve x by a 2 by 3 plus y by b 2 by 3 equal to 1. Density being rho equal to cxy. So our goal is to find out the centroid, and basically for that we'll be making use of, our main job would be to find mx, my, and by doing this we can just find out x bar as mx by m, y bar as my by m. So wait, we have to go step by step. And to find out the total mass, the formula, we already know the formula. That is, one second. Yeah, the formula for m is this integral dA, or basically it's like you have the density and dy dx, dx dy, whatever you call it. So in this case you have the mass as the density is basically kxy, you have dy dx, and the limits, yeah. So for the limits, what do is we have the equation y by b 2 by 3 equal to 1 minus x by a 2 by 3. Basically you express y in terms of x. Upon simplification you just get this. And yeah, one thing I'm not sure why we got it, but they tell that x varies from 0 to a, and hence because of that, wait, I'm sorry, I'm not sure why it varies from 0 to a, but maybe because of the boundary conditions or something. And you have, because of this, you have y varying from 0 to x by a, 2 by 3, 3 by 2. So just put this back in the formula for the mass. Oops. Okay. 0 to a, 0 to b into 1 minus x by a, 2 by 3, this is 3 by 2, and you have x y dy dx. So first let's integrate it with respect to y, because the variable x is varying from 0 to a, basically constant. So this is just going to be a into 0 to a, you have x and y square by 2, just put the limits for y square by 2, that is going to be 0, and b into 1 minus x by a, 2 by 3, and here you have 3 by 2, and you have dx. Once you substitute back, you have kb square by 2, like just put this inside, 0 to a, x into 1 minus x by a, 2 by 3, and then 3. That square and the 1 by 2 just get cancelled, and here it's like difficult to solve it just as it is, so you make a substitution. So just call t as x by a, 2 by 3, basically this part. By doing this, we have x as a into t power 3 by 2, and let's differentiate, and we get 3 by 2 a, t 1 by 2, and dt. So now put this back again, put it back, and you're going to get m equals kb square by 2, 0 to 1. And how did we get 0 to 1? Because at x equal to 0, t equal to 0. At x equal to a, t is just a. My bad, t is equal to 1. So what do we have now? Yeah, we have a t 3 by 2, because x is 3 by 2. I mean t power 3 by 2. 1 minus t power 3, and then yeah, this part also we have to write instead of dx. That is going to be 3 by 2 a, t power 1 by 2 dt. So we'll get our mass as 3k by 4 a square b square, 0 to 1 t square 1 minus t cube dt. You know what, just put this in the calculator, okay? Put in calci, and you'll get the final result as equal to ka square b square by 80. We're not done yet, this is just one part of it. This part is done. Now we have to find out what is mx first, and mx and my. So if we start with mx is just double integral, and you have y into density dA. This is basically kxy into y dA. So you have mx equal to kb cube. Wait, no. What are we putting back? Wait. you have b here. Okay, you have fine. Yeah, basically you put back the same stuff, that is whatever you're taken for x, sorry, y, b into that stuff. So you have kx b into 1 minus x by a 2 by 3, and this is just 3 by 2, I suppose. Yep, 3 by 2. And remember, you have a square term, and then you have dy dx, right? And oh wait, my bad. Yeah, this integral is not there. Basically we evaluated the first integral and that had the limits. So this is basically, this goes from 0 to b into 1 minus x by a 2 by 3 3 by 2. This goes from 0 to a, and once you do this, you'll end up with this. And once you simplify this further, you're gonna get k and 2 by 3 0 to a 0 to a x into 1 minus x by a power 2 by 3, and this is just 9 by 2, and you have dx. So yeah, you're putting the same stuff, like the same substitution, by a 2 by 3, and here once you do that, you're gonna get yeah, just don't mind me skipping steps, okay? You just do the same process and you're going to end up with this. Now same thing, this part you use your calculator, and you should end up with 8ka square b cube by 2145. And then when you do the same procedure for y, that is, you do my equal to integral x rho dA, that is basically your k x y into x dy dx, and this goes from 0 to b into 1 minus x by a whole square, sorry, not whole square, it's gonna be b into 1 minus x by a power 2 by 3, and this power 3 by 2, and this goes from 0 to a. Fine, the next step would just be integrating with respect to y, and you get kb square by 2, the exact same process we did twice already, and you get x square into 1 minus x by a 2 by 3, and you get 3 here because you have 3 by 2, and that 2 just gets cancelled. And again you're using the same substitution, and what was the substitution? T equal to x by a, okay, yeah, t equal to x by a power 2 by 3. Using this, I think you'll again end up getting my as 8ka cube b square by 2145. So we are done with mx, my. You just have to find x bar and y bar. So x bar is just mx by m, right? Which is going to be 128b by 429, and your y bar is going to be my by m, which is going to be 128a by 429. So we have x bar comma y bar equals 128b by 429 and 128a upon 429. So just please verify it from your side and ensure that this is correct. Yeah, so coming to the last page of these set of questions. So let's discuss the 39th one. So it says find the centroid of tetrahedron bounded by the coordinate planes and the plane x plus y plus z equal to 1, density at any point varying as a distance from the face z equal to 0. Yeah, so the total coordinate plane, so you have x equal to 0, y equal to 0 and z equal to 0, and the other plane that's given was x plus y plus z equal to 1. And they told that the density at any point is varying as its distance from the face z equal to 0. I think that basically means it's proportional. So density is just proportional to k, means it's proportional to z, so just bring a proportionality constant k times z, and we are required to find the centroid. So we'll be using the same formula which we did for the previous question. So yeah, we have the mass as integration of density into volume, and here the density is just k times z and dv is as it is. And about the limits in this, again you can go with the onion peel method and kind of like reverse onion peel method reverse onion peel method, I guess. So that is basically you've been given the function, now you construct the limits. So this one single function x plus y plus z equal to 1 is enough to get the upper limit. And it's left up to you which layer of the onion are you going to take as z, y and x. But as it is, we have z term here, it's better to take the larger function or the outermost one as z itself. So you have the upper limit of z will be z equal to 1 minus y minus x, or x minus y, and hence y will just be 1 minus x and x will be just 1, and the lower limits are all 0. This is what I failed to explain here, but yeah, good thing we realized it, this part. I think now you know why we got this, why we got that equation or the limits. So if we just plug this in, we have k into 0 to 1, 0 to 1 minus x, and you have 0 to 1 minus x minus y, and you have z dz dy dx. You have m equal to k into 0 to 1, 0 to 1 minus x. This is just 1 minus x minus y whole square by 2, because it's going to be z square by 2, and you put the limits. And once you evaluate this, I'm again sorry for skipping the step, but evaluate and get m as k by 24. So once you get k by 24, you have to find the x coordinate, and for that what you do is you need x coordinate and density dv by m. This is the formula, we know that. So x bar will just be, density is k times z, so it's constant. Pull that outside. You have this, you have xz dv Again, like you put the same limits, and you should be getting x bar as 1 by m into this integral is going to give you 1 by 120. Just solve it, please, I request you to. And you have k into 1 by 120. So you have x bar is 1 by m, we just found out. 1 by m, what was it? K by 24. So you have k by 24, which means that x bar is just going to be 1 by 5. That was probably a sick bike. Okay, yeah. Now you can see this equation, and it's like that one, and yeah, this one mainly. You can see that x and y are kind of symmetrical. If you would have taken x as 1 minus y, and if you would have proceeded, you would have gotten like the same answer itself. So you can tell by symmetry y bar is 1 by 5. So now our only headache right now is z bar, and yeah, it's just one small change for it. So z bar is 1 by m is the same, and just you have to integrate z into, a better meaning for symmetry, I would say, is you put y here and you put the limits, and you have z anyways here. So that is going to be very identical. Like when you do dx, dy, dz, you're going to get the same form. That's what I wanted to tell, like what I meant by symmetry. So now we have z, and the density is just k times z, and you have dv, and you get, you can write this as 1 by m, k is outside, integral z square dv, and again please integrate this, and you're gonna get 1 by 60, sorry, 1 by 60. So your integral, your value for z bar is going to be k by 60, and m is just k by 24. So z bar will be 2 by 5. So our x bar, y bar, z bar, they're just equal to 1 by 5, 1 by 5, and 2 by 5. So going to the 40th question. Find the center of mass of the region 0 to 1, 0 to x. The density is given by xy. Okay. So the given is the density is given by rho x, y is xy. Find the center of mass. Okay, fine. So first let's just find the basic, the normal, which is just integral density into volume dv. And what are the limits? The limits they've clearly given it to us. Again, the same thing, I've been telling it like 1,000 times. The constant limits will always be outside. So you have 0 to 1, which is x, and y will go from 0 to x. And the function is density, the given is xy, and obviously dy dx. This is 0 to 1 x, and with respect to y, so it's going to be y square by 2, and the limits are 0x dx, 0 to 1, and it's just x cube, 1 by 2 x cube dx. This is x bar 4 by 2, sorry, x bar 4 by 4, 2 and 4 cancel, and you get 2, you get 1 by 8. Fine. And oh wait, they don't cancel. Yeah, it's 1 by 8 only still. Yeah, just use the integration. So 1 by 2, 1, you get it 1 by 8. Yeah. And the next step would be to find out the x coordinate. The same logic, you have x into density dv by total mass. So x bar is x into xy into dy dx, 0 to x, 0 to 1. Let's go. And then m, let's keep it as it is for now. You have x square y dy dx, 0x 01 by m with respect to y. So your 0 to 1 x square is gonna be independent. You have y square by 2. Put the limits as 0 and x, and dx. This is just 0 to 1 x power 4 by 2 dx. Oh yeah, by m. This is going to be into x power 5 by 5, 0, 1 m. So x bar is just going to be 1 by 10 by m, and m, what is it? 1 by 8. So we have x bar as 1 by 10, 1 by 8. So we have x bar as 4 by 5. That's good. Now let's do y bar. And y bar will just be like almost the same thing, but it's just y into density is xy, and again dy dx. Put the limits as 0 to x, put the limits as 0 to 1, and write m. X is independent. You have y square y cube by 3, 0x dx by m. You have y bar as x bar 4, 1 by 3, just integral, and you have dx. Sorry, by m. Am I right? X bar 4, yeah. So y bar is 3 into x bar 5 by 5, 0, 1 m. This is 1 by 15, 1 by 8, and what is this? Y bar is just 8 by 15. Okay, that's a bit strange. I am not sure about this answer. I think our answer might be right, because I don't see any, like the 18 by 15 at least. I think it is 4 by 5 and 8 by 15. Please check. So let's finish off with, let's just do the 41st one. The solid occupies the region bounded by z equal to x plus y square and z equal to 4 and has the density. Find the center of mass. So we have z equal to x square plus y square. Then you had z given density. Alright, and you have to find the center of mass. And I think in this situation the best would be to use polar again. No doubt you can do it in Cartesian, but polar is what I prefer here. So you have the fundamental that is just gonna be equal to z. So what is r varying from? They've given, sorry, what is z varying from? From this thing to this thing. So we can just tell z is varying from 4, and what is x square plus y square in terms of polar coordinates? It's just r square. So z is sorted. Now again we have to find the shadow, and basically shadow in easier term, it's, they say, intersection. So if you take it in that way, it's just going to be x square plus y square is basically z, right? So z and z you're equating technically. So this is 4. So the radius here goes up till 2. So you have your radius r, which goes from 0 to 2. And as this circle is a proper one without any you know, what do you say, without any discontinuity, you have theta as 0 to 2 pi. So you have your limits, and you just need to find out, what do you say, yeah, you have to find out the mass. In this case, the mass is going to be the same thing, density into volume, z dv, because that's what they've given. And the limits are going to be r square to 4 or 4 to r square. It's, what have we taken it? We've taken it as 4 to r square. And this goes from 0 to 2. Theta goes from 0 to 2 pi. And dv is just going to be again, oh yeah, you had z dv is basically z dx dy dz. You're converting it into polar. So z is going to be, yeah, z is going to remain the same. Then the Jacobian will be r. You have dr d theta, and you have dz. My bad. But yeah, let's be sure about the order. We're gonna have dz first, because this is z. dz dr d theta. Right. So totally m is going to be what do you say? It's gonna be integral 0 to 2. You know, basically integrate z and you get z square by 2, and that would have given you r square minus 4 square is just 16 by 2, and you have r over here, and you have dr and d theta, and you can just write it as 2 pi into integral 0 to 2 16r. Okay, send the 2 outside. 16r minus r power 4. I hope I considered as r power 4. Did I? Oh no, it was r power 4 here. And after that, we have dr. Sorry, it's going to be r power 5 right now, because we have r power 4 here, we have r over here. So on multiplication is going to give you m equals pi into, yeah, I'll just put it in the calculator, and that should give you 64 pi by 3. And now we have to find the coordinates. Okay, the fun part here is that it is rotationally symmetrical. Like, it's like at the end of the day, if you see the shadow, it appears to be like a circle, and that is basically rotationally symmetric. So that's why you have your x bar equal to 0, y bar equal to 0. I'm sorry, I don't remember the proof of this stuff. Wait, give me a second, please. Yeah, I'm sorry, I don't remember the proof, but yeah, if it's like symmetrical, then it's just, this part is just going to be equal to 0. And then what about the coordinates for z? So you have z bar as integral of z into z, basically z, and the density is z, and then you have dv by m, and this is just, you just integrate this, like please do it yourself and you're gonna get this, the coordinates, like, basically you're gonna get this equal to 64 pi, and the mass we had found out was 64 pi by 3, so you have your z bar as 3. Yeah, so you have x bar, y bar, z bar equal to 0, 0, 3. So yeah, so we're done with 41. Let's move on to the last and final question. The temperature at any point, okay, bounded by the planes x plus y plus z equal to 1, is that okay? Find the average temperature over the solid. Okay, for the limits we have to use the reverse onion peel again. So they've told x equal to 0, y equal to 0, z equal to 0. These are the lower limits, and they've given another plane which is x plus y plus z equal to 1. And reverse onion peel is basically, once you find out what is z, you put z as 0, and then whatever you get 1 minus x, y equal to 1 minus x, put y as 0, you get x equal to 1. That is basically the like, that's what happens under the hood. For now, yeah, I think you can just remember that the limits for z will be 0 to 1 minus x minus y will be 0 to 1 minus x, and x will be from 0 to 1. And they've asked us to find out average temperature. Remember, average temperature was just like weighted average. So your average, so this is, yeah, the function f of x y z is basically this. So it's gonna be x plus y plus z plus 1 cube and dx dy dz, and what is it? Yeah, and divided by just dx dy dz. For convenience, for now, let's just call this as numerator and this as denominator. So for solving the numerator, we have the limits. So 0 to 1 minus x minus y, 0 to 1 minus x, 0 to 1, and this is just x plus y plus z plus 1 power minus 3, and dz dy dx, and that is, yeah, basically, again, I'm sorry for skipping it, but once you solve it, you are gonna get the numerator to be please for 100. So you have 1 by 2 log 2 minus 5 by 8, and you have what? Yeah, so this is our first equation, and when you have a look at the denominator, that is just going to be integral, same thing, 1 minus x minus y, 0 to 1 minus x, 0 to 1, 1 minus x, this is 1 minus x minus y, and this is 1 minus x minus, yeah, so here we were, and this is dz dy dx, and once you simplify this again, you'll end up getting the denominator as 1 by 6. This is fairly simple to calculate. So your final answer would be numerator by denominator, which is just 3, no wait, 1 by 2 log of 2 minus 5 by 8. Oh wait, it's log 2 minus 5 by 8 divided by 1 by 6. This is 3, so your answer is going to be 3 into log of 2 minus 5 by 8. Please solve. Please solve. And 3 log 2. Yep, that should be our answer. So yeah, guys, with that we finished all the questions. 94 pages is crazy. Yeah, so from here to 94 we went. I hope you guys understood, and I hope I am sorry for skipping multiple steps, because it's just calculation, and there's no point if I just spend time doing calculations. I hope you guys understood and found something valuable. If you did, yeah, definitely please share your experience down in the comment box. What do you feel? And yeah, it was pretty fun. So thank you. I'll see you all. Bye bye. So yeah, let me explain that rotation in spherical coordinates. Say this is the base axis, and say I have a vector, or basically a line, and when I'm going my lateral angle, okay, so right now my lateral angle is basically phi is 0, but when I move it like this, you can see that, say that this is the reference, and if here it is, the lateral angle is 0, whereas if I move this bangle, you can see that this angle, the one I'm showing on my little finger, that is the angle which is phi, so that is increasing, so it's here it's 0 and it's increasing. So basically when you have your bangle here, and when you move it by, this is 90-degree rotation, and once you bring that to another 90-degree rotation, you can see that it comes back to its position. Basically, if you have the bangle like this, if you rotate it just 180 degrees, you're going to get back this part at the top. So basically, when you move this part, even when you're moving the head, even the tail portion is covering some distance or subtending some amount of angle. So that's why just 180 degree is sufficient to cover the entire plane of the angle phi. Like phi being just 180 will be sufficient.